Hey there everyone, we are going to be building a 3D portfolio website using React 3 Fiber. One that not only looks visually impressive, but also interacts with the viewers in a fun and engaging way. We also have a 3D Fox animation based on our interactivity. If we are not interacting with the contact form, the fox will stay idle. If we press here and write something in our input fields, the fox will play another animation, like walking. And if we send an email, the fox will start running in joy. So you are not just building a website, this time you are creating an experience. I know it sounds like we are about to make a video game, not a portfolio, but who said that portfolios have to be boring, right? Before we start, just a heads up, this tutorial assumes that you have a basic understanding of React, but if you are new to it, no worries. I will try to explain every concept and each line of code. So I made this project with the absolute beginners in mind. Remember, coding is about exploration and fun. So don't worry if you don't get things right the first time. Keep trying, keep learning, and most importantly, keep enjoying the process. Let's not keep our 3D fox waiting any longer. Let's jump right in and let's make something cool together. Hey there, developers and future developers. Welcome back to this new series where we are going to build a 3D portfolio website using React 3 Fiber. You might be familiar with React and also with React 3 Fiber, but I know there are beginners that never heard of React 3 Fiber before, so they might have just raised an eyebrow and thought, what is this? Like 3 words into one, React 3 and Fiber. But don't worry, we are going to explain everything, also for the beginners. So React 3 Fiber is a powerful React reconciler for Three.js on the web. Three.js, now there is another eyebrow raiser for the beginners. But Three.js is a popular library, JavaScript library, for creating 3D graphics on the web. Think of it as the Lego blocks you used to play with, but for the web and, well, without the physical blocks. React 3 Fiber then is like an instruction manual that tells us how to put these blocks together using the rules of React. Another tool that we are going to use on this tutorial, which is very useful, is Drei. Drei is like our super useful tool belt that provides helpful components and hooks. We're going to explain later what hooks are, to make working with Three.js and React 3 Fiber even easier. It's like having an expert Lego builder giving you a hand, okay? And now that we mentioned what React 3 Fiber and Three.js are, we can start coding. The first thing first, we are going to use Vite to set up our project. Vite is a modern front-end build tool that significantly improves our development experience. For example, I used to use Create React App to build, but trust me, Vite is better and faster. You know how snails are slow and cheetahs are fast? Well, Vite is the cheetah of the development world, and yeah, it's blazing fast, and that's exactly what we need. So open your terminal and let's start by installing Vite. We can open the Vite installation page, and here you can see npm create Vite latest for the latest version of Vite, but if you scroll down, you will see here this long comment. It's like creating Vite and also creating the new project on your folder with a template of Vue, but we will use a template of React. Okay, so copy this npm create Vite latest my Vue app. Okay, let's customize it. npm create then Vite latest Vite latest, the name of the project, in this case my portfolio. Okay, dash dash template React instead of Vue. Choose here React, choose here JavaScript, and done. So we should have, okay, maybe I didn't create it on my desktop, but I think somewhere else. cd my portfolio. Let me see the path. Okay, I'm not on my desktop, but whatever. I will put it here, my portfolio. Now it's on my desktop. So we created the project with Vite. You want to open it with Visual Studio. And we are here. Now that our workspace is ready, let's invite our team, which are Three.js, React 3 Fiber, and Drei. Open your terminal in VS Code and use this command. npm install 3 at React 3 Fiber at React 3 Drei. Just wait a second. Once they've accepted our invitation and joined us in our project, we need to import them into our main application file. This allows us to use their functionality in our code. Now we are going to set up our first 3D scene. So let's break it down line by line. Here on our src folder, you'll see this app.jsx. And for now, we have like the default page from Vite. So to run the server, you use npx Vite and then click this URL. So we don't want this, we want our 3D scene. So at the moment, let's delete this React logo and Vite logo. This state variables set count, because now we are going to create our scene. Okay, so for this, the first thing it would be to import canvas from React 3 Fiber, because we need canvas. Okay, so import curly brackets canvas from React 3 Fiber. Also, we will import our module. We are going to get into that later, but for now, that's just imported. Model from, and he would be the path of our model that we will create, but it will be inside the assets. So assets, and let's say scene.jsx. We will change it later when needed. Now here, to return, we return the canvas. Inside the canvas, we will also import our model that we don't have it now, but we are going to create it very soon. So let's do that. Let's create our model. Let's download the assets and let's create the component for it. But before we are going to create a new model and add it to our scene, I would like to spend a few words on what Canvas is in React 3 Fiber. To understand what Canvas is in React 3 Fiber, let's first talk about what it is in the world of Three.js. In Three.js, the canvas is not a component or an object you can interact with directly. Instead, it's a term referring to the HTML canvas element, where Three.js draws your 3D scene. You can think of it as the stage where all of our 3D magic happens. But the process to get this stage ready in raw Three.js can be quite technical and involves interacting directly with the WebGL API, which can get messy. So here's where React 3 Fiber steps in and says, hey, let me make this easier for you. React 3 Fiber provides us with a component called Canvas that we are calling it here. And this Canvas component, it's like a bridge between the React world and the Three.js world. It sets up a 3D scene, but also the camera, render, and gives us a stage ready to host our 3D objects, all neatly packaged within the React component system. So when we are writing this canvas here in our code, we are not just creating an HTML canvas element. We are creating a whole 3D scene ready for us to add lights, shapes, animations, you name it. But here's the beautiful part. Remember how in Three.js you had to deal with all the technicalities of setting up the WebGL scene? If you have followed my previous videos on building a 3D art gallery, then you know. Well, the canvas component in React 3 Fiber takes care of all of that for us. So we can focus on the fun part, creating our 3D world. It's like hiring a backstage crew for a theater performance. They set up everything like the stage, the lights, the sound, so the performers can focus on giving a great show. So why is the canvas so important in our React 3 Fiber project? Well, everything we want to render in our 3D scene must be a child of the canvas component. Okay? So everything must be a child of the canvas component. You can think of canvas as the root of our 3D scene, the grand container that holds everything else. Okay? It's like the center of the universe. It's like the Earth in our solar system. Without canvas, there is no stage for our 3D objects, no place for the magic to happen. So understanding canvas and how it works is crucial, as it's the cornerstone of every project that you will build with React 3 Fiber. It's our starting point, our foundation. This is where we begin our journey each time we are creating a new 3D world. Hopefully that clears up what Canvas is and why it's so important in React 3 Fiber, but not only in Three.js as well. Okay? Now we are moving to add the 3D model on our scene. First off, let's take a second to understand what a 3D model is. A 3D model is like a puppet in our 3D puppet show. It could be a car, a person, a building, or in our case, a Foxy Island scene. And these 3D models are usually created in 3D modeling softwares like Blender or Maya, and then exported in a format such as GLTF or GLB in our browser. Alright, so how do we get our 3D puppet onto our React 3 fiber stage? And this is where Drei comes in, that we mentioned at the beginning. Drei, as we said, is a collection of reusable components and helpers for React 3 fiber. It's like a handy toolbox for our 3D projects. One of the most useful tools Drei gives us is the useGLTF hook. This hook allows us to load our 3D models, in our case our GLTF files, into our React 3 fiber project. And as you might remember from your introduction to React, if you have read it or if you have taken a course of React, a hook is a function provided by React that lets us hook into React features. In this case, useGLTF lets us hook into the 3D model loading feature. Okay? But I want to mention something here. Before we can load our 3D model, we want to make sure it's optimized for our web application. And here is where gltf.jsx steps in. This is a utility package. It's a nifty command line tool that transforms our GLTF model into a reusable JSX component and optimizes it for us. It's like a magical 3D model transformer. Okay? In our project, we will use this command. So open another window in terminal and let's see where I am. Okay, my portfolio. Navigate to this folder, assets, and then inside Fox Islands. So for that cd src assets Fox Islands. Let's check. Okay, we are there. Now that you are inside this path, my portfolio src assets Fox Islands here, where you have the scene.gltf, you should be here in the folder that has scene.gltf. Once you are there, where this file scene.gltf is, you need to run this command. But since I already have this utility package gltf.jsx, I can run the command. But you need first to install npm i gltf.jsx. Okay, run this, install the package, and after installing the package, run the command inside, always inside this folder, mpx gltf.jsx, the name of the file, which in this case is scene.gltf, scene.gltf, and then the option -- transform. I will explain what this -- transform does. It really makes our 3D model really light. It optimizes. It's like making it like even 90% lighter than it is, you know? So it removes many meshes that aren't used. It optimizes it, okay? And it will be much better performant in our web browser. So run this. And as you can see, it will create this component, scene.jsx. Let's click on it. Okay, this is the credits. We already mentioned the credits here in the license, so it's not a problem. And as you can see, we have this scene.jsx, which is the component converted from our GLTF file. So now it's a declarative JSX component. And you will see here, we are using this useGLTF from React 3 Drei that we mentioned before. And we are passing the path of the transformed GLB. This is a new file that was created with this package. It's like a better optimized version of our GLTF. And in the end, as you can see, we have a preload scene transformed GLB. So it will preload, so it will be better rendered in our scene, and it will be much faster. So the simple idea is that the option -- transform that we used here when we use the command of gltf.jsx, this option further optimizes the model, reducing the file size and ensuring our 3D scene loads quickly and smoothly. Okay, that's why I use this package always, because it really makes the 3D scene loading quickly and smoothly, and yeah, it's very reduced in file size. But now let's take a closer look at the JSX component created by this gltf.jsx package, which we are calling model. Okay, inside this model we are using the useGLTF hook to load our model file. We pass the path to our optimized GLB file, and useGLTF returns an object that includes our 3D model's nodes and materials. Next, we create a group to hold our model's various parts, also known as meshes. As you can see, we have different meshes here. Okay? Each mesh represents a part of our model, and we are setting its geometry and material properties based on the data from our useGLTF hook. Finally, we use this useGLTF.preload function to start loading our model as soon as possible. This helps to ensure that our model is ready to be displayed as soon as the user opens our application. Okay? And that's it, a summary of this file that was created. Then, in our app component, we add our model to our canvas. So, first of all, this is wrong, this path, so we need to fix it. So from src assets Fox Islands and scene. Okay. And here we can call our model. Okay. Let's see the browser now if we have any error or the scene is displaying correctly. Okay, yeah, we do have errors. 404 not find for the scene transformed GLB. Okay. Let's go to our scene component, and this is like not found. Let's do something here. Let's use a variable that uses this path. So import scene path from, we are inside here. Okay, so let's copy this. Okay, and let's use this variable here instead of the path. Also in the end for the preload. Okay. You should do this actually when we will deploy our website, because when we will deploy our hosting platform like Netlify, for example, or Versal, we'll use like a path for this because we will create a bundle. But yeah, I don't want to confuse you. Later you will see that we need to do it like this actually, okay? Because with a hard-coded path, the hosting platform like Netlify, etc., or Heroku or Versal will have problems and you will have some errors about this, okay? So we will check later in the end when we will deploy the website, because yes, we will deploy this so you can have it and show it to your connections, to your hiring managers, etc. So let's see if we solve this error, or okay, or if we have new errors. Let's check. Okay, we don't have errors, okay? And the reason that we still see a black screen actually is because it's dark out there, okay? We have no lights, so we need to have some lights in our scene to be able to see, of course, like in real life. If we are in the dark, we don't see anything, okay? So let's add some lights, and I hope you have some lights in your life too. But I want to mention something because maybe you are having an error here. Maybe you are having an error here, and I will explain how to fix that error. So if you are having an error here in your browser and you Google it and it didn't help much, because yeah, I know that, I will reproduce the error that some of you are having right now. Let me comment this, okay? Go to the browser. Okay, you see? So I think you are having this error here, right? Failed to parse source for import analysis because blah, 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 blah. This is a general information. It doesn't say much really. And for the beginners, especially, this is very confusing. So if you Google this, you will get some answers to Stack Overflow. They aren't really helpful because it's something specific. You will get some solutions for, I don't know, jQuery projects and things like that, that really, it will not help you, okay? So the solution is very simple. And this error is very simple to understand, even though it is not really so clear here. This message is really not so clear. It confuses people. The thing is that this GLB is not understood by Vite, okay? And here you see that in my Vite config.js, I added this line that fixes the problem. Oh, that fixes the problem. Assets include ** glb. Don't worry about that **. What does it mean? We don't care what it really means. The thing is that you need this Vite config.js and you should have it when you build your project. But you just need to add this. You see, we have this Vite.js plugin React, and in this function define config, you are using these plugins for React, basically. But you also need to include this assetsInclude, copy this and add it to this file, and it will solve the error. By adding this line and configuring this assetsInclude to include GLB files, you are basically telling Vite how to handle GLB files, and the import analysis error should be resolved. Okay? And that's it. It's just the way to tell Vite, hey, this is a GLB file, you need to read it because it's a GLB file, because Vite doesn't know by default how to interpret this. Really, you should not care about this to understand in depth. Just add this line and that's it. You are just telling Vite, hey, read this. It's a GLB file. Come on, read it. And that's it. And you'll see that the error is gone. We have a black screen. We are in our dark ages, but okay, we will add some light. And yeah, let there be light. Let's add it in our app component. And also add some other properties, because the model, the first time that we render a model, might have problems that they cannot see the model, they don't see anything, it's dark, or I don't know. So there are some problems like the position of the camera, the position of the model in the scene, I don't know, the scale. It's too small or it's too far. It depends. It depends like how the model is when you import it by its default values. So let's fix that. Let's start with our model's properties: position, rotation, and scale. In the world of 3D, these are the basic transformations you can apply to an object. So first, the position. Position is, well, where your model is placed in the 3D space. Imagine our 3D world as a vast, infinite grid with our model floating somewhere within it. By changing the position, you are moving the model along this grid. In our case, we are moving our Fox island to the coordinates of here. Position equal curly brackets inside brackets of the array, and with these coordinates 0, -5.7 and -43.4. These are the coordinates that I tested that our model looks good. Okay, so the coordinates are for X, Y, and Z axis. And next up, the rotation. This is where your model gets to do some gymnastics. The rotation property spins the model around its center. These values are in radians, not degrees. Okay, remember this. But maybe you remember your high school trigonometry? Maybe not? Okay, doesn't matter. But in our case, our island does a bit of a twist and twirl with these values. So here, after the position, add rotation equal curly brackets, brackets of the array, and here the three values for X, for Y, for Z. What I tested that looks nice are 0.1 for the X axis, 0.67 for the Y axis, and leave it to 0 for the Z axis. Okay? Now, finally, the scale. This can make your model look like it's been hitting the gym, or maybe it's been a while since its last meal, okay? So it depends on the scale. The scale property stretches or shrinks the model. So a value of 1, 1, 1 for X, Y, and Z keeps the model at its original size. Scale equal curly brackets, 1, 1, 1. Okay? I know that you are getting used already to this, and you see how easy it is in React 3 Fiber. I won't tell you how hard it is in Three.js, in raw Three.js. Those that already know Three.js already know how hard it is, to create all these things in Three.js. But it's really easy. Easy. I mean, the syntax and the way we are doing it, it's more intuitive, and we don't really know what happens in the back scene. So we call this position 3 values, X, Y, and Z, and you just here inside this module as attributes. I think it's easier to understand and also to write the syntax. Now we will add the camera properties and explain what they are in Three.js and in React 3 Fiber. Because what good is a beautifully staged model if your camera is pointing in the wrong way? Remember, the camera is your viewer's eyes in this 3D world. So the camera is the eyes. So let's set it up right. Add here camera. You see it is suggested, the property camera. Add another curly brackets here because it will be an object, because we will add several attributes. The field of view, which is FOV, you see it is suggested. And let's add a value of 60. This is like the zoom on a camera lens. A larger field of view means a wider shot, and a smaller one is more zoomed in. We have set ours to 60, a typical value for a balanced, natural-looking perspective. Okay? The other parameters are the near and the far. This set up the viewing frustrum, a big, invisible, pyramid-shaped space that extends out from the camera. Only objects within this space will be rendered. Okay? This helps keep our rendering efficient by ignoring objects that are too close or too far away. So, usually, or in this case, we will set the near to 0.1 and the far to 1000. So we are seeing everything from a 0.1 unit to the 1000 units away. Okay? So near, we set 0.1 and far 1000. Okay, if we go and open the browser, we still don't see anything. Okay? Before we wrap up, let's shed some lights on. In our scene, we are using 3 types of lights that I will add now. The first one is the ambient light. The ambient light is a soft general light that affects every object in the scene equally from all directions. It's like the base layer of our lighting. So here, below the camera, not inside the module, we will add the lights in the canvas. Here, add the first light, the ambient light. And very easy, like with the other components, it's ambient, you see it is suggested, ambient light. And let's add the intensity to 0.3. Next is the spotlight. The spotlight, it's a directed beam of light, like a flashlight or a stage spotlight. Let's add it. Our spotlight will be placed at the position of 10, 10, 10, and will give an angle of 0.15. This is the size of the beam. And also a penumbra of 1. The penumbra softens the edge of the beam. And finally, we will add the PointLight. The PointLight shines out equally in all directions. It's like a tiny sun. And we place this. -10, -10, -10. We will change later. It's just, to add some light, but we will fix the lights later. Remember, lighting is key for setting the mood of your scene. It's like the music in a movie soundtrack. It can really set the atmosphere. So, for now, these are some basic lights, but we can do better later. Okay? And let's take a look at our scene, if we can see anything. Okay, you see, now we see finally the scene. And it looks good, it looks okay. Of course, yeah, we can work even more with lights, but we can see the scene. And the position and the scale and the rotation looks good to me. We can change the color of the background, of course. If you are having some problems with the canvas, like the size, it's not like this that I have. I added some styles to it. I will show you. So in app.jsx, I added the margin and padding to 0. I added the background, but we can put a bluish background. We will fix everything later. The overflow hidden, we don't want to see, the scroll. And these styles for the root, so we have the canvas at the height of full viewport, also for the width, and display it flex, justify content center, and align. Okay, copy these styles and you can have the same result like mine. Okay, I made some changes for the styles, and now you see we have these clouds, they have an animation, and the scene looks better, right? But I'm not happy with the lights, and yeah, let's adjust the lights. For example, we can make it 0.5 the intensity of the ambient light, and let's see. Yes, it's better. Let's change a bit this spotlight and point light. For example, let's change the position on the y-axis of the spotlight to 50. Yeah, it looks better now. Okay, the scene looks good and we are getting there. Okay, guys, we are getting there. But maybe someone is asking, is there any other way to change the properties of the 3D model, the setup of the scene, the configuration of the camera, the lights, etc.? It's like doing it like this, manually change a property, then check, change a property, then check. It would be difficult and you might spend hours in a complex scene. So is there any other way to do this? A better way? Yes, there is. Remember the puppet show you loved as a kid? How you wish to control those characters yourself? Well, we are going to do the same thing and add some strings to our 3D models so we can change and control them, okay, in real time. To do this, we are going to use the OrbitControls and a GUI called lil-gui. Let's start by understanding what OrbitControls and lil-gui are. Well, I can quickly import OrbitControls into our scene. Okay, I simply imported OrbitControls from Drei and simply called the component here, OrbitControls. And now, if we go to our scene, you see, yeah, it's a handy tool like in the 3D software. This is the OrbitControls. The OrbitControls allows us to interact with our scene using the mouse and the touch inputs. So we can pan, zoom and orbit around our objects, giving you a complete 360-degree tour of your 3D world. On the other hand, lil-gui is a lightweight, user-friendly interface for tweaking variables in JavaScript. It lets you change your parameters in real time, seeing the result immediately. It's like a control remotely for your scene. Okay? You know the configurators that you have seen in your favorite 3D software or in Photoshop, Illustrator or Blender or Maya, that you open the configurators and you change the values there. The same thing we are going to do. Something like that. So how do we integrate this into our React 3 Fiber project? Let's start by installing the lil-gui package. This will be our remote control, remember? So open your terminal and run the command npm i lil-gui. npm i lil-gui. Okay, that's it. I already have it, but so you will install the package for it. Now we need to create a hook that uses lil-gui and we'll call it useGUI. So create a new file in our src folder, call it useGUI.js .jsx. This hook will create a new instance of GUI when our component is mounted, and it will also clean it up when the component is unmounted for a better performance, okay? To clean, unwanted memory leaks. Now let's add the code for this useGUI. First, import GUI from lil-gui. Then we need the use effect from React. I will explain it for those that aren't familiar with use effect in React or useState, etc. So use effect from React. Now let's create our component. Const use GUI equal the arrow function, and we pass here as parameter a callback. I will explain the arrow function, and here we will use the use effect. The arrow function inside this use effect, we create the variable GUI for our GUI, which is an instance of GUI that we imported. So to create an instance from this class is the keyword new GUI. I will explain in detail very soon. Now the callback and pass as parameter GUI that we just created. Then we return GUI.destroy because we said that we want to clean when we unmount. GUI.destroy. Okay. And here we pass as a dependency the callback. Okay, let me explain everything here, guys. So first we import GUI from lil-gui, which is the main class we are going to be using. Okay. Then we use the use effect React hook that we import from React. The use effect is like a sandbox where we can execute side effects that need to run after render, like setting up our GUI. Okay? The use effect is like a sandbox where we can execute side effects that need to run after render. In this case, we need to run the setting up of our GUI. Inside the use effect React hook, we create a new GUI instance. This is the container that will hold all our little sliders, buttons, and switches that will control our 3D scene. After creating our GUI, we call our callback, passing in the newly created GUI. This callback is where all the magic will happen. It's where we'll tell the GUI what properties we want to control. After setting up, we need to clean up our side effect. We use the destroy method on our GUI when the component using our hook unmounts. Okay? This is just housekeeping. It's always good to tidy up after ourselves. And we pass as a dependency the callback. So every time the callback changes, something changes there, the properties that we used, it will re-render this hook. So that's useGUI in a nutshell. But how do we use it? And that's where your module component comes in. Let's go to our scene component. Firstly, import the useGUI hook at the top of your scene.jsx file. Here, for example, import useGUI from useGUI. Now we want to use our useGUI hook to tweak the parameters of our 3D model. For instance, we might want to play with the model's position, rotation, and scale, because it's very difficult, as we said, to change the parameters, go and check the browser, like it will take you hours. Think about if you are in a team and working with a team, and you are the developer, but you also have a designer. So you don't want a designer for every small change like to tell you, hey, please go and change the position a bit, or please go and change the rotation. You know, it would be like a waste of time. So you create this debug configurator for the UI, and you tell the designer, hey, look, you have it there on your page. You can simply tweak the parameters and find the best results that you want for your UI. Okay? Think about it. It's way better and easier. Now we said that the useGUI hook takes a callback as an argument. Okay, here you see that our useGUI takes a callback as an argument. And this is where we will define what we want to tweak in this callback argument. So let's make some changes to our module component. The first thing I want to add here is a reference to the 3D model that we want to change. We want to tweak its parameters. Okay? And we will use for this the useRef hook that I will explain in detail what it is. But first, create a variable const groupRef and equal to useRef. Okay, we have imported this useRef here from React. I will explain now what this useRef is in React and also in our case in React 3 Fiber and how to use it. useRef hook is a React hook that allows you to directly access the DOM element or the instance of a component. In the case of React 3 Fiber, it can be used to get direct access to a mesh in our scene. For example, we can create a reference to a mesh using the useRef here, as we did, with the variable groupRef, and then pass it as a ref prop to the mesh component. And the mesh component is this whole group here. You see, this is our 3D scene. This is our Sky Island, because later we will add also other 3D models, not only the Sky Island, okay? So, for now, this is our 3D Sky Island. You will pass this prop like this, by writing ref equal curly brackets groupRef, the variable that we created here. This will allow us to directly manipulate this mesh object, or in this case the group, and we can change the position, the rotation and the scale of it. And that's it for the groupRef. Now let's use our useGUI hook. So here, useGUI, and as an argument, a callback function. Firstly, the code is all inside this callback function that we are passing to useGUI. Okay, this callback function. This function will be called with a single argument, the GUI, which is an instance of the GUI class from lil-gui. This GUI instance represents the GUI panel that's going to be added to our web page. It has methods to add different controls like sliders, color pickers, checkboxes, etc. Here we will only use the sliders, which we will add with the add method that you are going to see now. So let me add some comments here. This is our callback. It gives us the GUI instance to play with. We'll add folders for each property we want to play with. Okay, and now for controlling the position, the first thing, let's create a variable position folder, because we will create folders for each property that we want to play with. So const position folder equal to the GUI instance dot add folder method, and here we pass a name, position. I will explain also later everything. Now, position folder using the add method and passing the object that we want to control or tweak the parameters. In this case, our group ref. So group ref dot current and dot position. And here we pass x. This is the name. I will explain later after writing it. And the range. Okay, minus 100. This range is the minimum and the maximum. So minus 100 and 100. So the same thing for the other axis, y and z. So quickly create them, y and z. Okay, now for the rotation. Basically the same thing, we create a variable, rotation folder, and assign it to the GUI, add folder, and here rotation. We do also the same thing basically for the rotation, but instead of the group ref.current.position, we add group ref.current.rotation. Okay, so let's copy this and change from position to rotation. Okay, X, Y, Z. It looks okay. And now for the scale. Control, scale. Same thing. But here, change it from 0.1 to 10 for the scale. So, okay. Let's try in the browser if we see something. Okay, yes, it works. We see the position, the rotation, and scale. Let's try it. So the scale, yes, it works. Okay, let's change it again to 1. Let's try the position. Yes. Y-axis, Z-axis, and the rotation. Okay, for the rotation, let's try something else. I'll show you. So for the rotation, instead of this minus 100 to 100, we will, because the rotation is a circle, so we will use the method math.py, the built-in method. So I will show you. The first one will be from 0, so from 0 to the full circle. So we want to rotate from the point 0 360 degrees. So the full circle. But we will do it in radians. So for full circle, we use the formula math.pi times 2, because math.pi is 180 degrees. So we use this formula, math.pi times 2. Okay, let's try. Yes, okay, a full rotation. Also this one, a full circle rotation, you see? And in z-axis, okay, it works perfectly. Now, let me make a summary of what we did here. Firstly, as we said, all the code here is inside this callback. Okay, and this callback function takes this single argument, GUI, which is the instance of the GUI class from lil-gui. Okay, you see, it's an instance of this GUI class that we get from lil-gui. So the callback takes the GUI as an argument, and this GUI represents the GUI panel that we want to add to our web page. And we are using the slider here. Then we add the folders. Next, we are organizing our controls into 3 folders. One for the position, one for the rotation, and one for the scale. We do this with the add folder method, which creates a new collapsible section in the GUI panel, so we can control it. So here you see that we have this collapsible panel. Then we are giving each folder a name that corresponds to the type of transformation they control. So the position, rotation, and scale. Then we add the controls. Inside each folder, we are adding the controls for the X, for the Y, and for the Z. These correspond to the 3 dimensions of our 3D space. Okay, you know the axis X, Y, and Z. And we do this using the add method on our folders. So this is our folder, rotation folder or position folder, and we use the add method to add the controls. This add method takes 4 arguments. Okay? The first one is the object that has the property we want to control. And here, groupref.current.position, groupref.current.rotation, and groupref.current.scale. Then, the second argument is the name of the property we want to control. This is just the X, the Y, and the Z. So, the name of the property that we want to control. The third argument is the minimum value of the slider. And this is the smallest value that the property can be set to. Okay? For position and rotation, we are arbitrarily setting this to -100 for the position and to 0 for the rotation. And for the scale to 0.1. These values might need to be adjusted depending on your specific need. Okay, so you can play with it. The fourth argument, as you guessed it right now, is the maximum value of the slider. This is the largest value that the property can be set to. And again, we are setting this to 100 for the position, and for the rotation, we are using the math.pi times 2, which is the full circle in radians. Okay? This is the full circle in radians. Because math.pi is 180 times 2, a full circle, 360. Okay, and for the scale, we are setting the maximum value to 10. Again, this can be adjusted and you can play with. So again, to recap, what we are doing here is creating a new control for each component, the X, the Y, the Z, of each type of transformation, the position, the rotation, and the scale. So this gives us the panel where we can control each of these components individually, okay? As you saw in our browser. And you can see the changes in real time. I hope that this was clear for you. If anything isn't clear, please don't hesitate to comment. Alright folks, I think that now we should take a road trip from Upville to Homepage City. And what I mean by that? At the moment, our app.jsx houses our application. It's like the control center of the spaceship. It's filled with canvas, okay, with OrbitControls, and with lightings. Now, that's all well and good if you are just working with one single page, but we are aiming for multiple pages, so it's about time we moved house. Okay, so let's get to moving. We are going to shift our canvas, our lights, and our lovely 3D model into a new component named Homepage. It's going to be the belle of the ball, the main attraction, the first thing that our users will see. Then we will have other pages like About Me, Contact, etc., etc. Or also the page for displaying the projects, because it will be a portfolio website, right? But let's do it now, this refactor, because later so it will not be a pain. And it's always a good practice to always follow since the beginning, you know, the clean code, the project being modular, etc. So first, let's add a new structure for our project. Let's make the architecture of the project. So in our folder, src, let's add some folders. The first would be the components. Another folder would be for the pages like About Me, Contact Me, etc. The pages usually are those components that will have a route, okay? So it will have like at the top in the URL /homepage /about /contact, you know? So those pages. Other components that aren't like routes or pages, we will put it here in the components. So components, page, and maybe config for some config files. Okay. Inside the components, let's add our app component there. So create a new folder, app, and inside this app, let's add app.jsx and app.css. Okay. Also, let's add our homepage here in components or in pages, but let's add it first here in the components. So create a new folder, home, and inside home, two files, Homepage.jsx and Homepage.css. Okay. Yeah, at the moment we just need this homepage because we will move our app component to this homepage. But I wanted to add some new features. The first ones are a background music with a button to play or to stop the music. Add a logo, then we need a navbar at the top or at the right as a sidebar. So let's create these first components that we want to add. So the play button, okay? And also we need some media constants that we will put there our files, like, you know, MP3 files. And for the play button, let's put it here in the components. Create a folder, play button, and 2 files inside, JSX and CSS. So play button JSX, play button CSS. And for the media constants, let's create a new file here in the config folder, media constants JS. Okay, I will add this, copy paste the media constants. You will change it yourself depending on, you know, the files that you have or where you put these files. All right, we have the structure. So now we can start and move our app.jsx canvas and the other elements to the new component homepage. Okay. And first, let's import all the files that we need. And here I will do it quickly. Then create our component. I have a shortcut for that. RAFC. Okay. And now we have this homepage component. But I want to take all this from the app.js and put it here. So inside the return function. Now our canvas is inside this homepage component. Let's refactor here our app.js. We can remove this. We don't need it anymore. Here in our app, we just need to import our homepage. So import homepage from homepage. Also, I need to import the BrowserRouter from React.router DOM because we need to add the routers. Remember, we have different pages which are the routes. So for that, I will import this BrowserRouter as router, routes, and route from React.router DOM. I don't have this library because it's a separate library in React. The router DOM is separated from the main React, so we need to install it. For that, as always, npm I, open a new terminal window here, npm I react-router-dom and install it. Then after installing it, we will use it here in our return, and I will explain why and how. So here, let's use router, then inside routes, and then the route. Don't get confused, please. I will explain everything. And here inside the route, we will add our homepage component and set in its path. So the path will be slash, because that will be the URL for the homepage, okay? Usually we have a slash. And here, to add our homepage component, we use element equal curly brackets and our homepage. Okay, and that's it. Now I want to explain what we are doing here. What are these router, routes, route, what is React router DOM, and why we are doing this? But the answer is very simple. Without going, deeper and deeper into React router DOM, the answer is simple. We want to use different pages in our application. So the main scene, the Sky Island, will be our home page with this path here, slash. When the user clicks on this URL on slash, or if the URL is simply the home page without, adding other, queries, we will be redirected to this component. So if in our URL we have slash, we will be redirected to this component. Later, we will add like here, about or contact, and we will redirect and add this, the same thing, element, and here, contact, etc. We will just need to add another element to add other pages. Simple as that. You just need to get used to the initial idea, how to use these routes. So we imported this BrowserRouter here at the top, and this good friend helps us manage different pages in our application called routes. So remember, the routes are simply the different pages in our application. And then we wrap everything inside of this. And we just tell where to go using the routes and the route component. Okay? That's it. Simple as that. For now, don't worry about, going deeper into React Router DOM. For now, you just need to know this. We need different pages in our application, and these different pages are called routes. Okay? So to set each route, we just add another element here. Okay? You add the path like about, then contact, etc, etc. Okay? And here you change the component to contact, about, and the other pages. At the moment, you just need to understand this, that the route component is to define our application's path. In this case, our root path, this one, the slash, corresponds to the homepage component. The element here is like the magic phrase open sesame, which tells the route to open the homepage whenever we visit the root path. Okay? That's it for the routes. Or at least that's it that you need to know right now. Now let's see what errors do we have here if we go to our browser. So failed to resolve app.jsx from main. Okay, yeah, because we changed the structure. So on our main here, yeah, we need to change this import path because we changed, we added the folder up to our components folder. So components up. Okay, that's it. Let's see what errors we have now. Identifier React has already been declared. Okay, we have a double React import in our homepage. So here and here. Okay, I see. And this is gone. Failed to resolve config media constants in our home page. The path is wrong for our media constants, this one in our home page. Okay, let's see. Let's see what VS Code suggests us. So config media constants. It seems correct. What else do we have now? The requested module, our scene, 3D scene, does not provide an export named island. Oh yeah, I added the name island here, but it is module in our scene. You should change it too, guys. So that's because we will add other modules, so we want like a better naming than model, because we will have different models. So okay, only here. Change it to island. Okay, it does not provide export because how we are importing it. It's not about the island, it's about play button. Okay, I didn't see. Does not provide an export at homepage. So the play button. Let's try it like this with curly brackets, because without curly brackets is when we like do like this, export default. But if we are not doing like this, for example, how it is, I think it is export const in our play button. Oh, we don't have anything. That's why. Okay, we don't have anything here. That's why the error, but just comment it for now. We will add now the play button that I said I want to add the play button to our scene to play some music in the background, because yeah, who doesn't love some background music in our magic 3D island? And I was thinking about the music by Joe Hisaishi. He's a composer for the background music of Studio Ghibli animated film, The Moving Castle. You know, the title is Merry-Go-Round, I think, if I'm not wrong. Yeah, Merry-Go-Round. It's the soundtrack of the movie The Moving Castle from Studio Ghibli. That is very nice music, but I am afraid to put it because I think YouTube will, you know, stop my video because of the copyright. I'm not sure if it has copyright, but I think it has copyright. So maybe we will find another music that is copyright free. But I really like to put that one actually, because I think it fits perfectly our Foxy Island in the sky. Anyway, we will check later. So, do we have errors now? Okay, so many errors. OrbitControls is not defined. Okay, OrbitControls. Where are we calling OrbitControls? Here. Actually, we don't need anymore the OrbitControls. I think we can remove it because now we needed OrbitControls, you know, to move with GUI and to find the right position, rotation, and etc. But since we will do the logic to drag with the mouse, and by dragging we will display different sections of our portfolio website. So we will display our experience, etc., etc. So we don't really need OrbitControls anymore. I hope you are clear with what OrbitControls are that I explained before. So let's remove. Do we have errors now? Come on. Model is not defined homepage. Okay. So we had island and we need island here, not model. Change it, guys, from model to island. Okay, no more errors. Finally, we refactored a bit from our main up to the new component homepage, and we don't have errors now. We can continue on implementing this play button with the music playing in the background. Okay. Also, we will add the logo. We need a logo, so you know our application looks a bit better. We need a logo here. I don't want the navbar at the top because you know it will cover a bit our 3D scene, and I don't think it would be the best design because we know we need this 3D experience. So maybe we will add a navbar here that will be, you know, hidden with an icon here, a small icon. If we click the icon, it will open at the side. So it will not cover the 3D scene. But first, let's add the music. Then after the music, we can think of the navbar or maybe the logic to drag and rotate the island. By rotating the island, let's display an info box with information like, hi, I'm Emilian, etc., etc. with different sections. Okay, we will think about it later. For now, let's add the music. To add our play button, let's add first a div to act as a main container. So to wrap the canvas and also the HTML elements. And a shortcut to quickly create a div with a class name. Write dot, add the name of the class that you want. In this case, homepage.container, and press enter. It will create this div with class name homepage container. Okay, I also want to add an empty tag because in React, if you have more than one component or, different elements, it will give you an error because you need to wrap with the main element. So a main div or an empty tag. Okay. Now we can add the play button. And we said that we have this component play button. It is empty at the moment, but we will add the code later. So let's call it here. Close it. Then what else we need? We need a state variable, which will be a boolean, true or false. And we will call it isPlain. So isPlain true or false. Based on that, we will add the condition and the logic for our feature. And here I will explain one of the most important concepts in React, the useState. Okay? But let me write the code and I will explain in detail for the absolute beginners. I think I have a snippet code for creating the useState variables. So useState, yes, I have a snippet here. So use the snippet without pressing the keyboard, write the name of the variable that you want. In this case is plain, and again without pressing anything, press tab, it will go to the value of the useState. So these are, pro tips to work faster. And this will be the default value of this state variable. And by default it will be false. Now that we created this state variable, let's start with a bit of theory. In React, state refers to a part of the component where we can store values that may change over time and that may affect what is rendered on the page. When the state changes, the component will re-render to reflect those changes. Sounds cool, right? Well, in the olden days, only class-based components could have this state. But then the React team said, hey, hold my energy drink, and introduced hooks in React 16, I think 16.8. And among them, they introduced also the useState hook, which allows us to add state to functional components. So not only the class-based components would have the state. It's like getting the power to fly without needing the whole heavy Iron Man suit. Isn't that cool? Now let's turn our attention to our code here. Const is plain, set is plain, equal useState false. You see this line here? This is where we are using the useState hook. But what is happening here? To explain, when we call useState, we are doing two things. First, we are creating a state variable. In this case, isPlain. And this variable is going to store whether our audio is playing or not. It's like we have hired a tiny virtual assistant whose the only job is to remember if the audio is currently playing or not. And that's its job. Well, a good job, I would say. Second, we are getting a function to update this state. You see, setIsPlain. We are calling it like this. This is like having a remote control to command our assistant to change their mind. The setIsPlain function allows us to update this state variable isPlain, and anytime we do that, React will automatically re-render the component to reflect this change. Notice how we are passing false to useState. That's the initial value of isPlain. So initially, this value is false. In other words, when our component first appears on screen, the audio is not playing. So isPlain is false. You get that? So to be able to use this state variable and the function that updates it, we will pass them as props here in the component play button. Then we can use it inside the component. Okay? You will see and you will better understand it. So let's pass the props here. So isPlain equal curly brackets because it's JavaScript. Remember, always in JavaScript. In React, we use the curly brackets. That's how React recognizes that's a JavaScript code. So isPlain, we pass isPlain. So it's just a prop. We tell that this isPlain will be used here as isPlain prop. The same thing with setIsPlain equal, use this prop, setIsPlain. Now, on our play button component, since we have these props, isPlain and setIsPlain, we can use them. Because here we will add the logic to toggle the on and off. So on, play the music, off, stop the music. So the first thing is I need the media constants because there I have saved the music file. So import media constants. Well, since we are here, also import the CSS. Play button.css. Let's use the shortcut RAFCE. It will create an arrow function with the export default. Okay. And we said we can use these props, isPlain and setIsPlain. So here, curly brackets, because it's an object, we have more than one prop. And here we pass this as arguments, isPlain and also setIsPlain. I hope I wrote it correctly. But to be sure, I will copy paste because yeah. Okay, these are the props that we passed here. You see, we passed this isPlain as isPlain, setIsPlain as setIsPlain. And here, instead of a div, we will return a button. This button will have a class name of play_btn. Also, this button will have an event listener attached to it. So when we click this button, what we want is to toggle on and off. So basically we want to toggle the state is plain. Okay? So toggle it from false to true and true to false. So for the event listeners, you know from JavaScript, but if you don't know, we add an onClick event listener. So onClick event listener, that is suggested here because it's JavaScript that gives it to us. And with this onClick event listener, let's add inside the arrow function, which will take this setIsPlain, this function to update this state variable. So here equal arrow function. And when you use only one line, you don't have to write the curly brackets here for the arrow function, but you can directly put it in one line. So return what you want to return. And we want to return setIsPlain. And this setIsPlain, we said, is the function that can update the state variable. So in our case, we want to toggle to update it. Every time we click it, we want to change the state variable to its contrary. So if it's true, false. If it's false, true. And JavaScript has for that the exclamation, how do you say it? The exclamation mark? Yeah, exclamation mark. Exclamation mark of this is plain. So exclamation mark is plain. So basically JavaScript says that when we click this button, fire this function that updates the state variable. And how you should update it? You should update it with this exclamation mark. So the contrary of this Boolean value. If it's initially false, turn it to true. If it's true, turn it to false. Okay? This is what this onClick function does. It toggles the value, the state variable value, from true to false, from false to true. And here, instead of play button, we want to show an image, an icon. Okay? Because we have the icons here in our media constants that you will edit your icons. Or if you want to use mine's, and you can copy the way that I did with these media constants. Like I'm importing logo, music path, play off icon and play on icon. So we said here, instead of play button text, we want to display, if the music is playing, we want to display the play on icon. If the music is not playing, we want to display the play off icon. So conditionally. And in in React, actually, because we are on React 3 Fiber, to do this, we use the ternary operator. Instead of using if, else, if this, do that, we cannot do in React with if, else, because it doesn't work as we want it. In React, usually we use the ternary operator. And to use the ternary operator inside the component of React, we open the curly brackets. As we said, when we use JavaScript code, we open the curly brackets. And the Boolean is plain is self-explanatory, the naming, is plain, and the question mark. It's like if. In this case, is plain, question mark. Open the parentheses here. And the first will be for the true condition. So is plain, the first condition. And for the first condition, I want to display the play on icon. Then img self-closing tag, and here we use the source path. So src equal, let's add the path here, but I don't need the strings here because the strings are when we put the URL taken from the browser. Here I want to use this media constants, which is imported here. And this media constants, I can access the other variables. So music path is what I need. You see, is Hisashi and mp3. So I can use it like media constants dot music path or dot play off icon, play on icon. Okay. So let's use this music path. Remove the strings. Open curly brackets because we are using JavaScript here. And media constants dot play on, in this case, play on icon. Because is playing, yes, display this play on icon. If it is not, and here if it is not, after the parenthesis here, open another parenthesis, and we set not the play on icon, but the play off icon. Okay, so here play off. Is it play off? Yes, play off. You see? So we use the Ternary operator. Is playing, question mark, open the parenthesis, and we put what we want for this condition. Is playing, then display this icon. If it is not, then, how do you say in English this? I forgot. However, if it is not, play this play off icon. And that's it. It's like saying, if condition, do this, else, do that. Okay? And we have the code for our play button component. Now we can finish the logic in our home.js. In our home page, we need the useState hook, and also we need the useEffect hook. This useRef and suspense, we don't need it right now. We will need it later. But we need these two, useState and useEffect. We used the useState already, what we explained before. Now we will use this useEffect. And you are familiar by now with useEffect because we already used it. And why we need this useEffect? We need it because maybe you have asked yourself the question, how does React know when to re-render our components when we change the state variable? Like, okay, we changed the state variable, but how does React know that we change it? So if we toggle the button, play music or stop music, how does React really know that the state was changed and now you should re-render the component? This is where the useEffect hook comes in handy. The useEffect hook allows us to perform side effects in our components. We already mentioned this. For example, we fetch the data from an API. We set up event listeners. Or in our case, we play the audio. The useEffect hook takes two arguments, a function that contains the side effect code and an array of dependencies that will tell React when to run that function. But okay, saying it like this with words, it will confuse you. But I will repeat what I said by writing the code and you will understand it, believe me. So useEffect, we don't need to create a variable like const, etc. We simply call useEffect. So useEffect, open parenthesis, and inside we said that this useEffect takes two arguments. One is the function that contains the side effect code. So let's set the function that contain the side effect code. So create inside an arrow function, so another parenthesis here, because you know the arrow function is parenthesis equal this arrow and curly brackets, okay? And here will be the side effect code, and the side effect code is our audio and the logic, what we want to do with that audio. The audio or the music is the same thing. We are calling it audio. So let's create the variable first, audio, because we need a variable. So also you need to have this problem solving, this process thought. Okay, we have this use effect. I just learned that the use effect takes two arguments, and the first argument is a function that will contain the side effect code, and the side effect code is our audio and the logic that we want to play it or not. Okay then, so to have the audio, what we need, first of all, we need a variable. So I don't want to create tutorials to be spoon feeding, so every time you need to do a small task, you come back to my tutorial. No, I want you to learn how to think, how to solve the problem. Okay, I need the variable. Watch me, I need this variable. Watch me how I code. Now paste this, copy that. It's not a tutorial really. It's just copy pasting. Maybe for some people it would be nice because they just want to grab a project. They don't really want to learn. They just want, just to get projects from YouTube or from all over internet. But to be honest, that's of no use. It's a waste of time. It's the truth, guys. It's a waste of time. So the only thing that you will really improve is to struggle a bit, to put the process thought in action, and to know how to do things yourself. You need a variable. You are creating a variable. Why? Why are you creating this variable? It seems like a stupid question, but it's all there. Like, why do you need this variable? Okay, you need the audio. Why? Why? Because here, in this use effect, that will be the function that will have the side effect code, I want to put the logic for the audio. So the first thing first, I need a variable. Start from this. So const audio. Let's create a new instance from the audio class of Three.js. And in this case, we are on React 3 Fiber. It will be simply audio because the naming is always intuitive in Three.js and also in React 3 Fiber. This audio, in the back scene, this audio is from Three.audio class. But here we just, call it audio. And we put inside the path. And the path is from our media constants. That I forgot, I think music path, right? Check again. Yeah, music path. So media constants dot music path. Music path. All right. Then, since we are here, we have this audio source. We want a volume, right? Maybe it's too high, maybe it's too low. Let's set the volume like in the middle. To set the volume, always the naming is intuitive. Audio dot volume equal 0.5, 0.4, 0.5. What else? Maybe we want it to loop. So since we are here, let's do it now. Why do it later? Audio that loop, it will be true. Okay, we have the basic things for the audio, and following always the same logic, not of a spoon feeding tutorial, but of a process thought and problem solving tutorial. So we have the audio source and we have this first argument of the useEffect, which is this function, which is the side effect code. What we want to do with the audio, we said that we want to play it if the state variable is true, and we want to stop it if the state variable is false, which initially is false. And for that, we created a toggle in our play button component. So let's add that logic in our useEffect. Simple as that. If true, if isPlain is true, isPlain. So if you write it like this, if isPlain, there is no need to like equal true, because a variable like this is true by default. So if isPlain, meaning if true, as JavaScript reads it, then play the music. And for that, always the naming I set is intuitive, audio.play. And play as the parenthesis because it's a method that plays the audio. Okay, and you guess it. If not, else. So if isPlain, play the audio, else stop it. So pause it. For that, we just return. We need a function here, arrow function, because this will have another function, not only to pause, but I will tell you now. To pause it, audio.pause. Parenthesis, we said. Okay. So if this variable is true, we will play. If it's false, which is by default, it will pause the audio. This function here in this return will serve also as housekeeping, because this will stop the music when the component unmounts, so it will clean up. Okay, so if the state variable is false, stop the music, or if the component unmounts, we exit the page, or also stop the music. And maybe some of you already forgot, but when we created this useEffect, we said that the useEffect takes two arguments. Do you remember what I said before without going back? I said that the second argument takes an array of dependencies that tells React when to run that function. Because we raised the question before, how does React know when this state variable changes and it should re-render the component? How does React know? And this is why we use the useEffect, because here as a second argument, by putting a comma and an array of dependency, we put what? We put the state variable, which we asked ourselves, how does React know when this changes? React knows by putting this in this array of dependencies, okay? Which is the second argument of the useEffect. So now React knows that every time this isPlain state variable changes from true to false, from false to true, re-render the scene, re-render the component. By re-rendering the component, it will affect the changes that we made. I hope it's clear. If it's not clear, trust me, go back again to listen to this, and I am sure that you will understand it. Take my word. But just not follow and simply that, but please code and stop and try to understand what we are saying step by step, and then just reproduce it with your mind the process thought as we mentioned. Try to understand what we are really doing here, okay? And I'm sure you will understand it. If you have any question, please don't hesitate to ask or to comment, or, we can discuss it together. Let's see what errors do we have, because we always have errors in our browser. Okay. Yeah, I know we have errors. Play button is not defined. Play button is not defined. This one is not defined, right? Yes. Why it is not defined? Because we comment it out. Okay, let's see. Another error, of course. Failed to resolve import play button CSS. Does the file exist? No, it doesn't exist. Yes, it exists. Play button CSS on play button. So here. This doesn't exist. It says play button.css. What, it doesn't exist? Why? The requested module play button does not provide an export name. Play button. Okay, we don't have an export default, or what? Oh, this is the export default, so remove the curly brackets. Audio. Please use the new operator. Failed to construct audio. Didn't we use the new operator? Oh, I forgot the new operator. Yes, it is right. Because when we create a new instance, so new audio, new instance of the audio class from the object-oriented programming. Every time we create a new instance, we have the class audio. And that class audio usually has a constructor. And that constructor has some default arguments that we pass. Okay? We call that constructor, we create a new instance, but I don't want to confuse you with the object-oriented programming, but the simple idea is every time we use a class from Three.js, like audio, or, material, every kind of classes, and we create a new instance, we use this keyword new from the class audio. Let's see. Okay, we have no errors. But what is this? It is our button, right? It is working. Let's see if I click, if it happens. Yes, the music plays. I don't know if you hear it because I have my headphones, but it works. I don't know if the audio is... It works. Of course, we should add the styles for it, but we will do it. The logic works. So let's grab the styles from our app.jsx. The styles in the body. And add it here. Yeah, of course, we need to target the class here, which is homepage container. Okay. This is for the animation of the clouds. Maybe the only thing is to add the width and height of the viewport. So width and height. Let's check. Okay. Now the island is back. We should fix this play button now. Add the styles for it, but the main scene has the correct styles. You see the clouds are animating, the island is showing where it should show. Let's add the styles for the play button. So play button. We should have a class for the play button, right? Okay, this one, play btn. So let's target that, play btn. The styles for our play button. First of all, we need to put it at the bottom. So basically here, like 20 pixel from the bottom and 20 pixel from the left. Let's do that. So to do that, we use the position absolute. Then bottom we set 20 pixel and left also 20 pixel. Yeah, since this play button is the container of the image of the icons here, let's make it display flex. So dflex, justify content center, align items center. Let's add the width and height of 72 and height 72. There is a shortcut, guys. You write H and 72 per pixel, enter, and you add the styles quickly. Pro tip. Also the border radius of 72, but border none. The line height 72. The cursor pointer, when we hover the mouse, it will point. And Z index, because we want the button to be above the canvas so we can see it. So Z index 10. And also background for that. Background color. Like an orange color. Okay, it looks better. We also need the styles for these icons inside, and maybe on hover put some styles. So to target the icons, we have img, okay, img, play-btn, img. And let's put the width and height of 24. Height 24. Yeah, it looks nice. Now the styles for on hover. Play btn. Hover. Background color. Okay, it looks good to me. Let's leave it like this. It looks okay. Now, I want to add the logo here. So we need the logo. Then we can go on with the navbar. But let's first put this logo here so it looks better. So in our homepage, to add the logo, here, above the play button, We created a div with a class name logo container. Let's add an image. And the path will be our media constants dot logo, I think, if I'm not wrong. Curly brackets, media constants dot logo. Let's check. Yes, logo. Okay, we see the logo now, but it needs some styles, like, the same thing as the play button, a bit of margin and padding. And let's add the styles for this logo on our app.jsx. So that logo container. The same thing, position absolute. Let's add the top to 70 pixel and left to 90. And also Z index to be above the canvas. Let's see. Okay. It looks okay. For the image inside, okay, this is what I want. Let's leave it here. Now we have the logo and the play button. We can continue making the navbar or making the rotation of the island when we drag the mouse, and by dragging the mouse and rotating the island, let's show different sections of our portfolio website. So our experience, then by dragging show another section like our projects and so on. I think let's add first the info box when we drag the mouse and we rotate the island, because this is the main design actually. So let's add that first, and we will create the navbar when we have the other pages too. Okay, so let's finish this main 3D scene. Let's create a new folder for the info box here in the components folder. New folder, info box. Create two files. One for the JSX and one for the CSS. Okay. Also, we need to create a new folder and name it profile sections that will contain inside all the sections that we will display on our 3D scene. Okay, we rotate the island and we will display all those profile sections. So let's make it like we started, modular. So let's create a component for each one of those cards that we will show. Okay, so here, not in the components, but in our src, create a folder, profile sections, and inside we will create a folder for each of these info boxes that we want to display. For example, the first one, intro card, our intro, the first step. And yeah, you can skip this part, I will make it quickly. So a folder for each section and also two files, one for the JSX and one for the CSS. Now let's import all these components. Okay, I imported all this, what a pain. Let's create our info box component. So the shortcut RAFCA, it will have a class name of info box. And inside, instead of this info box text, we will call all these components based on the stage that we are, because we will create a logic like we have this island, okay? And this island is a full rotation 360 degrees. We will convert this in radians, okay? So we will divide it, let's say, in 6 sections. These sections will be our thresholds. So when we pass from this second threshold, the third, the fourth, etc. Okay? So based on these stages, we will display a specific card, one of these, okay? We will calculate that in radians. So if I am on the first radian, on the second, or on the third, because, you know, the island, the full rotation is a circle. I will explain everything. Don't get scary. So the logic will be, if I am on the stage 1, display the intro card. If I am on the stage 2, display project card, and so on. And I said the logic of the stages will be this, that we will divide the 360 degrees, convert it into radians, and we will divide it in 6 sections, okay? So the logic will be current stage equal to 1, show the intro card. And for that to show, React has a very handy syntax that is like this. And show the component. Okay? So if the current stage equal to 1, then show intro card. This syntax here is, you know, very short. It's like, if this is true, then show it. Okay? Also, let's do it like this quickly. You press Shift, Option, and the arrow down. Or I think is Alt, CTRL, and arrow down for Windows. 1, 2, 3, 4, 5, 6. Okay. And here let's change this. So the first, here the second. Then we show our applications. Then we show our project. Then we show our status. Then we show our current job. Okay, so we will display this based on this stage that we will create the logic later. No worries. But the idea is, if we are on this current stage 1, show this. Current stage 2, show this. So 2, 3, 4, 5, 6. And how do we get this current stage? This current stage state variable will be a state variable. Remember the play button that we created the state variable and the function to update it with useState with a default value? The same thing we are going to use here. We are importing the useState, and we will add our logic based on this state variable, which is the current stage. Okay? Because all the logic here is based on this current state variable. Okay? But we are not going to create it here. We are going to create it to the component that will call it. Okay, so the parent component, and the parent component is the homepage. Okay, so it's better to add the logic here and then pass it here as prop. Remember how we passed the state variable as prop for the play button? We passed it from the homepage here. Where's the play button? Okay, we passed it as prop. Is playing and set is playing. So the play button then has these state variables. Okay, the same thing we are going to do with the info box. So inside this parentheses, curly brackets, because that's an object. So we will get this current stage that we are going to create on our homepage. Okay, I'm commenting this for now, but because I will get an error because they are all empty. So don't worry if you get an error because they are all empty, but I don't get an error now because I'm not calling this info box anywhere. I'm just creating it, but if I call it here in our homepage, I will get an error because they are empty components. Okay, so we have the logic here for the info box. Here's everything okay and done. Maybe later we can console log this, you know, to show the current stage. And pass this current state variable. Now let's go back to our homepage because we have the component here and it looks okay. Oh, last thing, maybe we still need another logic here, and we are done with this component info box for the class name. The class name now is info box. So here I want to make this visible if the current stage is not 0. Okay, so if it's not 0, make it visible, this div, this whole div. So let's add the simple logic here. Open the curly brackets, add the backticks, add the class info box, then $sign and curly brackets to use JavaScript code. And here we will add the ternary operator, the condition. If it is greater than 0, the current stage is greater than 0, then make it visible, the info box. If not, an empty string, so display nothing. Current stage greater than 0, question mark, then make it visible. If not, the code for the ternary operator, empty string. So display nothing, display an empty string. Okay, and that's it for this component. We are done with this. We can now go and work with our homepage component and also with our scene.jsx component for the 3D model to add the logic of when we drag with the mouse or when we use the touch, we can rotate the island, and by rotating we show different profile sections of our 3D portfolio. And by the way, I already created the profile sections here. I created a folder inside components and added these 6 components here for each profile section. Okay, but I'm not going to do a tutorial on that because really it's just JavaScript, HTML and CSS. You can create your own design and display it here. Okay, like a text, like I did, or you can add your own design. Or if you are lazy or you don't really want to do it, just copy the code from my project. I also made it for mobile, so it's mobile responsive. So go and just copy and paste to your project. Now let's go to our homepage and first import the info box. And we said that we need a state variable for that, current stage, which is the one that we passed here as a prop. remember, current stage, and that we are using. Based on this, that this changes, we will show each of this one here. Okay, so the same that we did for isPlain, we will create current stage, set current stage, and the default value will be 1 because it will start from the stage 1. It will display the intro card. Now that we have our current stage, let's add here the info box component. So just at the top, below homepage container, here, calling the component info box that we imported. And let's pass the prop. And now you should be familiar how to pass the props in React. So create this kind of variable, current stage, pass current stage as a prop. Okay? This one is what we get here and what we use then here. So we have the info box. We have the state variable that we are using on our info box, and it should work correctly. Yes, we see it. You see, this is stage 1. We are console logging it here. In our info box component, we are console logging it, the current stage. So we should see in our console info box current stage 1. Let's check. Okay, info box current stage 1. We are console logging it. It works. Now, of course, we cannot see the other info boxes, the other sections, because we don't have the logic to rotate. Because the logic will be to divide, you know, the island in 6 sections. And based on the position on those sections that are thresholds, we will display these info boxes. But we don't have the logic for that. We will add it to our scene.jsx component. But we can see the first one. So this works perfectly. So the first thing we want to do is to pass this set current stage as a prop from the homepage component, which is the parent, to the scene component, which is the 3D model component. Okay? So here, in the island component, pass set current stage. And you should be familiar with this by now, because we used it before. So set current stage, we pass it as a prop, okay? And here in our scene.jsx, here, as an argument, we see we have props, and we can use it like this, like props dot set current stage. It accesses this by props dot set current stage. Okay. For example, if you are using it here, you write props dot set current stage, etc. Or I usually import every single prop here because I want to know what are the props that I am getting on this component. Okay, because I want to know. I take a look here at this object. It will be an object. And I know what are the props that I get. And I simply use them directly. So set current stage, etc. Not by props.set current stage. Okay, this is how I use it. And here you do this dot dot dot, which is like every other props. And here we pass our set current stage, comma. Okay, so I know that I'm using this set current stage. Also, the other props, the rest of the props. Okay, we pass the prop. The next thing, we need some state variables here. The same thing that we did with isPlain and current stage, okay? You are familiar with it now. We explained what useState is, etc. We already have the useState here and also useEffect. If you don't have it imported here, we need this useEffect and useState from React. Also, we need useFrame and use3 from React 3 Fiber. Also import this. Okay. If not, you will get error later because we will use this useEffect, useState, useFrame, and use3. We already used it before, the useGLTF and useGUI. So you already have it. But I think you don't have this. Okay, so import it. And here, what we need is, first, I need to get the viewport from the hook use3. So const the structure viewport equal use3. The viewport gives us information about the current viewport, meaning the visible area of the 3D scene. So we need this. That's why we are importing it. Also, from use3 hook, we need the GL. And this GL is the WebGL rendering context from React 3 Fiber. Okay, so get WebGL rendering context from React 3 Fiber. Visible area of our 3D scene. Some comments so you know. Next, let's create the state variables that we want to use. And the first one is the rotation. So rotation, set rotation, and the default value for it will be 0 because we will start from the value 0. Another state variable is dragging boolean. IsDragging will tell us if the user is currently dragging the mouse or the touch if we are using a mobile. Okay? And the default value for it will be false because initially we are not dragging, so it will be false. The logic says it. Another state variable will be last x that we are calling it. Last x will store the last known x coordinate of the mouse or of the touch point if we are using the mobile. So the last known x coordinate of the mouse or of the touch. Last x, set last x, and again it will be 0, the default state. Now we have the state variables that we need. The next thing we want to do is to add the event listeners. And we need some event listeners to be able to, to register the mouse inputs. And for our event listeners, we will start from the first one, which will be for the pointer down. So we will need the event listener handle pointer down. Handle pointer of the mouse or of touch, drag start. Handle pointer down. Handle pointer down is an event handler that is called when the user starts dragging with the mouse or with the touch. Okay? And it will set the isDragging state variable to true, and that's it. Then we will update our last x variable to the current x coordinate. Follow me, please. Don't get confused. You will understand everything in the end. So const handle pointer down equal arrow function, and here we pass event as an argument. And we said that what we want to do with handle pointer down is to set isDragging to true. Okay? So for that, you should know by now that to set our state variables, we use the function set. So to set isDragging, we use the function set isDragging. So call it set isDragging. It's a function. So add inside true. And it will set the state variable to true because initially it is false. So we will listen for the mouse or the touch if we are dragging, and if we find out that we are dragging, then set isDragging to true. It's logical. Always think of the process thought, what you want to achieve and how you can do that, and what are the tools or the function, the methods that JavaScript or React or whatever language provides us, okay? Okay, we said that we want to set the dragging to true, but also update the last x to the current x coordinate of the mouse or of the touch point, okay? So for that, this is it seems a bit more confusing, but don't worry, I will explain. So let's add a comment here so we understand it better. If it's a touch event, so maybe we are using the touch from the mobile, then we will use the first touch point that we get. And since it's an array, we will get the 0 index from that array. You will see here. Use the first touch point. Okay? So create the variable client x for that. Client x equal. And here we will use the ternary operator. You know now ternary operator because we used it. And maybe if you've completely forgot about that, it's normal. I remember the first times that I used ternary operator, it looked like weird to me. It didn't feel natural. I don't know the syntax. Initially, I only wanted to use if statements, if else. I was used to that. When I first used React, I really hated this ternary operator, especially if you are using it inside the JSX element. It's like, really, it's horrible. You know, use the ternary operator, you open the parentheses, one parenthesis at the beginning, then you have some JSX elements, and then you use like it was, and really, it is horrible. I really not a fan of the ternary operator in React, especially because it's okay, like, you know, as a syntax, but in React, it's not so, it looks ugly to me. For example, Vue.js has a better way to handle this. It's like, you know, vshow, and it feels better to me. But this is another discussion. So we have this variable client x, and we will use the ternary operator to check if there is a touch event, because maybe we are using, you know, the touch. Then use the first touch point. So for that, with the ternary operator is simple as a syntax, even though I don't like it. Event that touches question mark, it's like you asking. So if there is, for the if statement, in this case with ternary operator, event that touches question mark. So this is the condition of if, you know, if event that touches, then event that touches, we set it's an array, and we will get the first touch point. So to get the first touch point in an array of touches, we get the first index, which is index 0. Okay? Index 0 of what? Of client x. Or if it is not a touch event, set it to event.clientX. So not event.touches, but event.clientX, which eventually will be the mouse. Then client X. Okay, that's it. Then the last thing, we said we want to update the last X and set it to the current x coordinate of the mouse or of the touch point, which will be this client x. This client x, we said, will be the mouse event or the touch event. So we want to update this last x, which is the last coordinate, to this current client x, okay? It seems a bit like confusing, but it is not so as it seems. You just want to read it again and, go through again. So we said that we want to update a state variable. We use the function set that updates it, okay? So set last x. It's a function, so we pass inside the value, client x, this one. I hope it is not confusing, but let's move on with the other event listener, which is, I think you guessed it, it's handle pointer up in this case. And handle pointer up, it's not drag start, but it's drag end. Const handle pointer up equal, we pass again the event here, arrow function, and handle pointer up is called when the user stops dragging, the contrary of handle pointer down. And it will simply set this dragging to false. Okay, that's it. So set is dragging to false. Okay. Handle pointer down is when we start to drag, handle pointer up when we stop dragging. So here we set it is dragging to true, here we set it false. That's it. Easy peasy, right? Then the next, this one is a bit, okay, maybe it's a bit harder to explain, but maybe not that hard. I know that you can understand very well what I'm going to explain. But if you have any problem to understand it, just rewatch it. But if you again have problems, which is normal, guys, it's really normal. It's not that I'm an expert. I really struggle too, with things that are new to me or. So it's normal to not understand something, to struggle with it. But I promise you, the more you struggle, the more you will learn. Actually, that is maybe the only way to really learn something and be good at it. Struggle, okay? Yeah, it's true. Also, the gym bros, no pain, no gain, is the same in programming. You should struggle to understand something because the brain works like that. Okay, it's like a gift from our evolution. The brain only remembers things that are essential or, to survive. So when you struggle with something a lot, the brain understands that, oh, this should be really important for this guy. He really struggling trying to understand this. So this coding thing should be really important for this one. So let's try to remember, let's try to understand it, It really works like that. Because the brain only wanted to remember things that would make the person survive, But yeah, sorry about this lesson of evolution. Let's continue. This is not something that I should talk about. I'm not an expert on that, but yeah, this is just my thoughts. And here we said handle pointer move, the new one. Let's put the comment here. This is to drag, just to get, the position of the X we will going to explain. So handle pointer to drag. Const handle pointer move. Pass the event arrow function And here, I need to explain a few lines of code. The first thing, I will check the condition if we are dragging or not. And we have this is dragging to check for that, okay? So if we are dragging, if is dragging, but after checking if we are dragging, we also want to know, I said, follow the logic when you create things, you know, okay, I am checking if I'm dragging for this handle pointer move, but I also want to know if it's mouse or touch, right? So if touch event, the same thing. This comment here also, yeah, this whole code here, okay? We explain this. If it's a touch event, use the first touch point. So the client X will be is touch event, use the first touch point. If not, use the event that client X. That event that will be, if it's not a touch, it will be eventually the mouse. Yeah. Okay. Now, if we are dragging with this handle pointer move event listener, we want to calculate the difference between the current and the last X coordinates, which we will call the delta. So const delta, it will be equal to this formula, which is client X minus last X, okay? Because we said we want to calculate the difference between the current and the last X coordinate, which is client X, last X, divided by viewport width, okay? Because we want to know where is this coordinate in the viewport, the visible area of our 3D scene. Then we will update the rotation based on this difference, okay? The current X coordinate and last X coordinates. Based on this difference, we want to update our rotation. We create a variable for that. Let's call it new rotation. Const new rotation equal, and here we will use rotation, the state variable that we have, rotation, plus this delta, which is the difference that we mentioned, plus this delta times the constant. We need a constant here, and the constant is times math.py, and that's like a small factor to control the speed. I will explain, no worries. So here times the constant, the mathematical constant pi, which in JavaScript is math.py, which is a built-in method. And let's add a constant of 0.0 something to, you know, to control the speed, because the higher the number, the higher the speed, the slower and the lower the speed. So let's say it is 0.002, because yeah, it will be too much. Trust me. So we said that we want to update the rotation based on this difference, okay? So to update our state variables, we know now set rotation and add inside this new rotation variable. Okay, and the last thing, also update the last X to the current X coordinate, okay? Update the last X to the current X coordinate. So set last X, the current is client X, this one, this guy here, okay? Maybe this is a bit confusing, maybe it is not. For someone it will be easy peasy, I know, the advanced guys, and maybe they are laughing at my explanations right now. Maybe I'm not good at explaining this, but bear with me. I'm trying to explain it. For the guys that are beginners, I advise you to check and, play it again. Try to understand. Check the browser, what we are really doing here. Okay, so we are dragging and we want to check if we are dragging or not. After we are dragging, we want to create variables for the last X position and also update the rotation based on this, changes from the last to the new. And we want to update rotation based on this difference because we want to measure how much, we drag. So rotate based on this. So check the video again, maybe this part. We will take a look now at the result in our browser, how we are doing it, what is the result of this. And I think you will understand it, okay? But if it's easy to understand already, I hope so. If you are, I don't know, having an issue with this to understand, leave a comment or suggest me, leave a feedback. What I'm doing wrong in explaining this, I'm not the best developer in the world. Okay, we have this and we are getting there. After creating these three event listeners, handle pointer down, handle pointer up, and handle pointer move, we want to do something. First, we want to add these event listeners to the canvas, okay? Because it's there that they will work and listen for something to the canvas, okay? So when the component mounts in React, the component mounts the first time it renders, we want to listen for all this. Listen for dragging, listen for touching, etc., etc. Then we want to remove these event listeners when the component unmounts. And this is important, guys. Remember this. This is important to prevent memory leaks. We want to clean up, okay? Do some housekeeping. For this, we will use the use effect that we used also before. Register event handlers. Use effect. Inside, open this, add the arrow function. We will get the canvas element, okay? And that's why here we get this GL from use3, which is the WebGL rendering context. So get the canvas, const canvas equal GL, this guy here from use3, which is the WebGL rendering context from React Fiber, dot DOM element. You know DOM element? You know that, right? In JavaScript. And we are getting the canvas element. Now that we have the canvas, we can register these event listeners. And for that, canvas, to add the event listeners, we have the method addEventListener. Also, this is pure JavaScript. So canvas.addEventListener. And here inside the parentheses, we pass the name, pointer down. You see, it's suggested, pointer down, comma, and we pass the function that we created here, which is handle pointer down. Where are we? Okay, here. Okay, the same thing for the other two event listeners. So quickly pointer up, here pointer up, and pointer move. Be careful, this is not like camel case. No, this down, up, and move, they are not uppercase here, like here. They are all lowercase. So be careful, because you will get errors. Okay, so we registered these event listeners when the component mounts. But we said that we also want to remove them when the component unmounts to clean up and prevent memory leaks. For that, we use this return function here, arrow function. But yeah, and the same thing, but not add event listener method, but remove event listener. Simple as that. Canvas.remove event listener. And yeah, again, we pass these guys here. So pointer down, comma, and pass the function, the handlers. Quickly add them. Oh no, I said to you, be careful not to add this uppercase, and I did it myself. Okay. See, it's a common error. Only these are like camel case. This one are all lowercase. All right. So to summarize, in this use effect, we are adding the event listeners to the canvas when the component mounts and removing them when the component unmounts. This is important to prevent memory leaks, we said. Next, the last thing, I promise. Maybe not the last thing, but yeah, follow me, please. Now we will create the section thresholds. So we will define the rotation thresholds for each of the 6 sections of our portfolio. Each section spans 60 degrees, which we convert then to radians by multiplying them by the math.pi. Don't get scared by the word pi. We will get there. It's easy, I promise. It's just, some numbers, but it's not advanced math. We will be able in the end to understand everything. So let's create the section thresholds. Here, always some comments. So 6 sections, okay? Think about the island to understand it better. Think about the island, it's a circle. And think about it like it's a piece of cake, like the American pie. And we will divide this in 6 pieces of cake, okay? In 6 equal pieces. So this will be our 6 sections. So divide the cake in 6 pieces. And each of them will span 60 degrees, okay? 60 times 6 will be 360 degrees, a full circle. But we want to convert this to radians. You know what radians are? Okay, maybe not. Don't worry, just don't care about it. Radians is just, if you quickly Google it, you will understand very quick. But to convert this to radians, we multiply them by math.py. Okay, these values. I will show you how. So to comment 6 sections, each section, we said, each section should span 360, the full circle, degrees, 360 divide 6, which is equal to 60 degrees. So 6 equal pieces of cake. So everyone is happy in the end to eat the equal parts. I remember a quote now from this that said that politics is like dividing a cake in 2 not equal parts, but making each of the parts think that they got the bigger piece. Okay, so it's true actually, but we are dividing our cake in equal parts. Okay, enough talking. I know that I'm getting boring. I know, bear with me. So create this array and let's call it section thresholds. Okay, equal to array, and let's add 6 thresholds for this. Okay, the first one, we said that we want to convert them to radians, and to convert them to radians we multiply them with the math.py. So the first one, math.py. Be careful here, pi is uppercase, P and I uppercase, because if you do like this, you will get errors. Math.py divided by 3. So math.py divided by 3, what does it mean? It simply means, remember, math.py is 180. So 180 divided by 3 is 60. So the first piece of cake, okay, the first radian. Then the second one, we need not 60 but 2 times that. So 2 times math.py. You know why I put this in parentheses, right? Right? No? Because in programming, like the rules of mathematics, we put the multiplying in parentheses. So the first thing we do the multiplying, then we continue with if we have like, addition, etc., etc. We don't want that to be calculated differently. So we want to be calculated 2 times math.py, then divided by 3. So it will be 2 times 180, which is 360 divided by 3. Okay, and it's 120, right? Right? Not sure. Comma here, don't forget the comma. Next, it will be, so 60, 120, then it will be 180. And for that 180 is the math.py. So math.py, no need to divide and do any crazy stuff here. Just remember, math.py is 180. The full circle is 2 times pi. So 2 times math.py. 180 times 2. Math is easy. It's not that hard. I suck at maths. I should admit I really suck at math. I'm not good at math. beautiful people, they say suck at math. So yeah. 1, 2, 3, the 4. The 4 here, it will be 4 times math.py, in parentheses, remember, divided by 3 again. So now it's your turn to do the calculations. I finished with the calculations. Now it's your turn. So 4 times math.py, 4 times 180 is 720, right? 720 times 3 is 240, right? Like, come on, help me a bit. 240, yeah, because 60, 120, 180, then we have 240. Yeah. I'm good at math. Then, yeah, 5 times math.py. We love pi. I know everybody loves these constants. They have some kind of magic. They have, like, you know, some mystery. It's like God put into this some of his knowledge. I don't know. They have some magic. Pi always amazed me. But anyway, 5 times math.py divided by 3 always. Yeah. And the last thing will be 360, which is 2 times pi. 2 times pi. We have these 6 sections. I know you understood everything here, because yeah, I'm a good teacher, of course. Here we need another use effect to update the current stage when the rotation changes. So we drag the rotation changes, and we want to update the current stage where we are, because I think you forgot, maybe. Don't forget. We have this current stage here, remember? This guy here. Based on this, we want to show the specific parts of our portfolio. So on the first radian, let's call it, it will be the stage 1. Then on the second radian, the second section, it will be the stage 2, and so on. So don't forget that. So here, update the current stage when the rotation changes. Okay. Use effect. The first thing here is to normalize our rotation to be between 0 and 2 times pi. Again, if you want to know what normalizing means in, in numbers, in mathematical, in programming, just do a quick Google search. So we want to normalize this rotation to be between 0 and 2 times pi. Create the variable normalized rotation, const normalized rotation equal, and this formula to normalize. Copy this formula here, normalize rotation to be between 0 and 2 times pi. Then we want to compare the normalized rotation against the thresholds that we created here to find the current stage. Again, please don't get confused. We will use this normalized rotation by comparing it to the thresholds, okay, to find the current stage. And the first thing here is we want a variable that we will name it section index. So what is the index of these sections? So we set 1, 2, 3, 4, 5, 6, etc. So section index. First it will be 0, of course. Then we will add a while loop. You know what a while loop is. And here, because in the while loop, we will check the condition. So if this section index is less than section thresholds, this array here, that length, and the end here, it's like when we want to compare something, a condition, but both of these sides, the left side and the right side, so this condition and this condition, both of them are true. Okay, this was what this end means. So both of these conditions are true. Only then do something. So if section index is less than the length of this array and normalized rotation is equal or greater than the section thresholds index, which we are. Section thresholds, we pass inside section index. This here, section index, that initially is 0, then it will change. So while this condition where both are truthy, increment the section index. So from 0 it will increment section index, you know, the famous ++. Okay, it was maybe a bit confusing. Maybe I'm not good at explaining it at the best way, but we will get there. And here, the last thing for this use effect is to update the current stage that we get as a prop, the set current stage. That's why we passed it here. We want to update this current stage after this. And for that, we use set current stage that we got as a prop. And inside, as an argument, we do section index, this one, +1. So we updated +1, okay? And here we should not forget the array dependency that we talked about previously, that when we pass a variable here in our array dependency of the use effect, it will re-render when that variable changes. In this case, we want to look for the rotation. When this rotation changes, it will check and render. Okay, that's it. I hope it is clear. I really hope it is clear for you. If not, please try to go step by step and maybe watch again the video and see the browser what is happening, that we will check now with the last thing that we need, and it will be hopefully working. The last thing is the use frame. The use frame is a function that we continuously update something. So it renders on each frame. From the name use frame, it renders on each frame. Is the equivalent that we do on Three.js of set animation loop function, where we, use it to usually for the animations because we want to render on each frame something. And it's very easy with this hook in React 3 Fiber. We don't need, the other settings configurations that we usually do with Three.js to set this. We simply call this use frame that we imported at the top. Simply call this use frame and here add the condition that we want to update on each frame. But this can be also a bit a problem if we are doing it wrong, because remember, this updates on each frame and that can be a bit expensive if we, do something which is wrong. For this, usually to update something, like in our case, we want to update the rotation. We change the mesh, the object that we want to target, with a group ref. In this case, we get a reference of what we want to manipulate and change it directly with that reference. For the reference, if you remember, we have the group ref here that we used at the beginning. You remember here. So ref is group ref. So we have a reference to this group of meshes, and this group is the whole 3D island. So we want to change the Y axis of the rotation of this sky island. So yeah, let's target this. If we check the condition, if we have this reference, if we have this 3D island, if it exists, if group ref, if true, but don't forget here, not simply if group ref, because it will not work as it should. There is a spider on my table. If group ref that current, the current object, then do something. What we want to do is this island group.ref. Again, don't forget current, because it will not work as it should. Group ref.current.rotation. Now you already know that rotation. That rotation.y equal to the value here that changes, that we are also using here in this use effect, the state variable rotation. Where are you? Okay, rotation. Okay, it should work. I hope so, because it was a bit hard to explain this part. But yeah, I will not edit it. I will leave it as it is, because yeah, trying to make the things perfect, as other YouTubers do, like they try to make it look like it's perfect, like, but I will not edit this part. I hope you understand it. So let's try. Okay, let's try. Oh, let's hide this before trying. I don't want any more of this. It confuses me. Okay, we have errors, of course. What are the errors? Code type error, assignment to constant variable. Assignment to constant variable. Yeah, assignment to constant variable. It tells itself, it's self-explanatory. So we are making an assignment to a constant. And you know that in JavaScript, you cannot reassign a constant, meaning a variable which we declare with const. Okay, so only with let we can reassign them, not with const. These are the very basics of JavaScript. But I make two very basics errors. So this is a constant, you see? And we are assigning it here. So plus plus, we are incrementing it. But we cannot if it's a constant. So it should be a let. Let's check. Yeah, it works. Okay, finally. You see, I also added this info boxes. And we are console logging. You see the current stages, that changes. We can also console log the normalized rotation values, but we don't really need it because the things are working finally. I hope it was clear, this part. Maybe it was a bit of, it's not that it's hard, but you know, it requires some code that maybe some beginners are not familiar to, like, you know, math.py, normalization of the rotation, you set the client tags, etc, etc. But don't worry, it's normal. There might be something new that you are learning, and it's completely normal not to understand. It's not supposed actually to understand something that you didn't try before. So no worries about that. Try to watch it again. Now that you see the picture of it, what you are doing, okay, this is the logic that we implemented. We click with a mouse or with a touch. Since we click and we want this to drag, because by dragging we rotate, and by rotating we display info boxes. So we check if it is dragging. We created this useState variables for that. After checking that we are dragging, we want to check again if it's a mouse, this, or it's a finger, it's a touch. So after checking that, we then created the thresholds, the 6 sections, the 6 equal pieces of cake of our 3D island. What is happening here? Okay. So after doing all this, maybe it will be more clear for you to understand that part. So we have done this. Let's move with the next part. Maybe adding the navbar, or maybe adding another fun part, which is the plane with its animation. So we want to add the plane to the scene and it will be animated. We drag and rotate the island, and also the plane will fly around our island. Okay? I think, yeah, we can do that because it's a fun part. Now let's create the component for our plane. Open your terminal because we need to convert our GLTF of our plane to a JSX component. And remember, we did that for our island with the utility named gltf.jsx. So open a new terminal window and let's get there. So where I am, my portfolio, so cd src bplane. Not such a file. Okay. Yeah, I forgot assets. So cd src assets bplane. Okay, I'm there. So make sure to put your model here in src assets bplane, then go to this directory and there use the command mpx gltf.jsx, the name of the file, which is scene.gltf, scene.gltf, then the option transform, transform. Now let's modify it a bit. Okay, we are not going to talk again about, because we already explained them with the first model, the Sky Island. But here, let's change this path to a variable, like we did with the island. So import scene path, because we will need this when we will deploy from scene transform, this new file that we created, the GLB, the performant one. Also here, in the use GLTF hook, and in the end. We can call this component to our homepage, import, what's the name? Let's change the name from model to bplane. Okay, and here let's add it to the canvas like we did with the island. We will also need some properties adjusted here, because usually we don't see anything. You see? Well, okay, we see, but not as we wanted. You see what a beautiful plane we have? It looks nice, but let's put it a bit down and adjust the scale and the position in the z-axis. So for the position, let's make it 0 for the x. We want to change it a bit for the y-axis, put it a bit lower in the screen. So minus for the bottom and positive for the up. The same as minus value for the left and positive value for the right. So -2 maybe, let's try. And for the z-axis, let's try 0 first, then we'll see. Okay, maybe the scale a bit smaller and the z-axis. The scale, let's try the default 111, let's see. Okay, looks good. Yeah, I think the size is perfect. Yeah, the rotation also looks perfect, so I won't change the rotation. Rotation. Zero, zero, zero. Okay. Yeah, I like it as it is. Now to our scene, and let's add the animation. You see here that apart from nodes, materials, and animations, nodes, you know, are the different parts of the 3D model. Materials are its looks, so you know, the color, the texture, etc. And the animations, when we have animations. So with the utility that we used, gltf.jsx, if the model has any animation, it will recognize it and it will add here. It will destructure it from the useGLTF. Okay, so we can use it. And also we see we have actions from use animations that takes as arguments animations and group. We can console log maybe the animations. So let's see what's his name, because we should target it, and so we will target it based on its name. So here animations. Let's see if we see something. Okay, animation clip. You see, we are console logging it. And animation clip, you see name is animation. Yeah, this is the name of the animation, animation. So we will target this name here, animation, because we have only one animation, you see? We have only one animation. Let's target that. So we have ready these actions here, and to use the animations we will use actions.animations. Okay, actions.animations. We have it already ready for us from the gltf.jsx utility. So we need the use effect. So here, use effect. Use effect. And it is very, very simple to create this, okay? And the way we are doing it is with a state variable, like we did with our Sky Island. So we will create a state variable. Is animating, so is the plane animating? A better naming, is plane animating? Based on that, we will play or stop the animation, because it will be connected with a dragging. So we want that when we start dragging, we also want the plane to animate. When we stop dragging, we also want the plane to stop animating. So it will give this feeling that the plane, you know, is flying around the island. Actually, we are moving the island, not the plane, okay? But by animating the plane, we will give this feeling that it's a plane that is flying around the island, okay? So we need the boolean, a state variable. Is plane animating? True or false? Based on that, we will start animation when is dragging, the other state variable that we created, is true. So if it's dragging, we will start animating, okay? Let's see how to do that. First, let's create this state variable, but again, we will create it here at the parent component, which is our homepage. Is plane animating? And you know that by default, the first time it will be false. Now, let's pass this variable that we will check as a prop to our scene component. You are starting now to understand things, how React works. Here, pass it as a prop. Pass it as a prop, simply like this. Okay, now you passed it as a prop. And remember, when we get a prop, we can use it like props that is plain animated, or simply to know all the props that we receive. I like to know all the props that I have. I take a look here at the arguments and I know what are the props that I am receiving. So it would be better to do it like this. But this is an object because we have some things inside. Okay, so we are receiving as a prop this is plain animating from our parent component is plain animating. Okay, now we can use this. Let's add also a comment here. Play or pause the plain animation based on is plain animating props. Here we will add the condition. We said if is plain animating, if it's true. And here we will target the animation, which we said had the name of animation clip. Yes, it has the name of animation. So let's target that with the actions. So actions that animation, it was uppercase that play. So we play that animation, which you found out that has this name here by console logging it. Okay. And else, you guessed it, it will be actions that animation, the name of the animation, that stop, not pause. Beware that in this case it was named animation. It's not that it's like a standard name. It will be different. This is just the name of the animation that the 3D modeler decided to give to it. Okay, it can have like I don't know, walking, running, you know, it is all simply the name of the animation. So you should console log it before to find out. So console log it here, find it the name here, and then use that, target that. And are you forgetting anything here? Remember when we talked about the use effect, that it takes this dependency array, and this dependency array is what use effect checks for and to decide when to re-render. So what values are changing to decide when to re-render. And here we pass is plain animating and also the actions. So if is plain animating will change true or false, we will re-render. And also when anything changes from the actions, the animation, it will re-render. Okay. Let's see if we have errors. Import is, who imported this? I have no idea. Maybe I clicked something and it imported automatically. Yeah, this one here, I don't know. It was imported automatically. Anyway. It is not animating, of course, because we forgot the last thing that we should add. So here we said that we want to play the animation when we drag and stop the animation when we stop dragging. And the logic for that, you remember, it was in the Fox Island. And we are handling this with this eventListener, handle pointer down. Okay, so this is for the drag start and this is for the drag end. Okay, so here we want to update our variable is animating. Okay, so here to put it set is playing animating to true, and here to update set is playing animating to false. But we don't have set is playing animating here, so the same thing, we pass it as a prop. So here this function to update the state variable, take it and pass it as a prop to our island here. Okay, and now that we passed it as a prop, let's use it here, the same as the set current stage. Okay, now we have this function to update our variable is playing animating. So here, when we are dragging, we want to set it to true. So simply call this function and set it to true. And here, in the handle pointer up, which is the drag end, when we stop dragging, set it to false. Let's see what happens. Okay, we are animating. You see the propeller? Nice. But what would be even nicer would be to, to have a sound for this engine, the plane starts animating, we want the sound of the engine playing. We can do that. I already downloaded a sound. You can find on Google, like search for plane engine sound. So you could find every kind of sounds. So download the sound for the engine to play, add it to your project. I have it on my public folder. It should be here, engine loop. Okay, is this one. But we didn't create anything about that. So here in our home page, so let's create a sound engine reference, okay, that will use this as a reference. So const sound engine ref equal to, for that we use the useRef hook, and here we pass a new instance of the audio class from Three.js. So new audio, this is the class from Three.js that creates the audio, and what we pass here, we pass that sound that you downloaded from internet. I have it here inside my media constants, and I don't remember how it is called. Let's see, logo music, engine sound. Okay. So I will use it like this, media constants dot engine sound. Here I can also set the volume for that. So sound engine ref dot current, because the reference has this current, that volume equal to, let's see, for the music background we have 0.5 volume. I don't want the two sounds, conflict each other. So let's put the sound of the engine like the lowest. So here 0.1. Now check this sound engine ref and pass it as a prop. You are now familiar with props, right? Pass it as a prop to the Sky Island. Okay, here. We have it as a prop. We can use it in our Sky Island component. So here we can use this. Okay, we have this prop. that changes that sound, decide what to do with that sound. But we need also another prop, isPlain, sound variable. isPlain, okay, this one. Remember the isPlain? If isPlain, audio.play, to play the background music, okay? So let's use again this isPlain, maybe to set, the sounds for it, because what I mean, here I want to let the users control the sounds. So here, on or off, it will mute all the sounds or, play all the sounds. So it can play the background music, but also the engine sound. By muting it, it will mute all the sounds. So let's use that state variable. To use it, pass it as a prop, again, to our island, isPlain. And here, in our island component, the same thing, this is the bplane, the same thing, here we are dragging, we control if we are dragging or not, in the handle pointer down, and here, when we are not dragging, we stop dragging, so handle pointer up. Here we will check the condition for if isPlain, then play the audio, etc. So here, if isPlain, did we pass it here, right? No? Okay, pass isPlain. Okay, if isPlain, no, we need this, okay. I passed it to the bplane, or no, I passed it to the island. Why I added it here? I thought this was the island component. Okay, sorry guys. I thought this was the island component. So I need that sound engine ref. I need it here on the island component, not on the bplane component, because I'm passing it here. Sorry. That's why I said, where is the prop? Okay. So we have sound engine ref and also isPlain props. So here I can use this sound engine ref dot current. Don't forget current when we have the reference. Dot play. Okay, that's it. The same thing, but in the handle pointer up. If isPlain, okay, but this time stop. So when we stop dragging, stop also the music and the sounds, all the sounds. Sound on? Okay, it works. It works, but the engine doesn't stop anymore. Let's fix that. The engine doesn't stop. Let's fix that. So where is the bug here? When we stop dragging, which is the handle pointer up, we use this. Okay, not stop, but pause. Let's try. Not stop, but pause. Okay, it works. Okay, it works. I won't leave the music because then YouTube will, stop my video because it has copyright. But it works. Perfect. And this is done. So we have also the plane flying around our island. It animates, it plays the sound of the engine. Everything looks good. What do you think? Now we can add the navbar and also the other pages, or yeah, I also have another module I want to add. It is like some birds. I would like to have, flying birds here. Would be nice. So also animated. So maybe, yeah, let's add some birds here that fly around together with our plane. Would be nice. Would add the touch of, the design. Then we can add an icon here at the beginning when we start the web application. I want like a hand that hints me to drag, because I don't know what to do here. If the user visits our page, maybe he doesn't know that they should drag. Okay, so let's add a hint, like an animation with a hand suggesting to drag. Okay, and with a text like click and drag to play, to explore. Let's do that. Now let's start by adding this drag hand animation. I will import this icon and I have it here on my public folder. So it's this one. You can find it, on internet. Now let's add a new state variable for this and let's call it show hint. Okay. By default, it will be true because the first time that the browser opens, it will show this drag hand animation to suggest to drag and click. So it will be true initially. Let's create the element for this here below play button. Let's create the JSX element, an empty tag because it will have several divs. And here let's add the text click and drag to explore. Now let's create a container div for the icon. Then another container. And inside this one, an image. The src will be this icon that I imported, drag hand icon. And the circle here. Add the class name for the image, the icon, hand icon. Okay, we have the element. I also added the styles. On my homepage CSS styles, you can add your own styles. It's just CSS. Here, let's use this set show hint conditionally, okay? So wrap this with the curly brackets and here use the state variable show hint and end. Wrap this with the parentheses. Okay, so this curly brackets is outside of this and wrap this with a parenthesis like a return. Okay. So this means that if show hint is true, display this. Simple syntax, okay? Is conditional, but is a simple syntax. So if this show hint is true, and initially this is true, because you see we have the default value. When we first render the page, it will be true. So we want to show this animation of the hand. So if this is true, show this. If it's false, it will not show. Okay? So we want this to show initially, and this initially is true. And if we are not setting it to false, it will always show because it has this condition of true and initially is true. So we need to set this to false, but when? The logic says that we want to set this to false when we start dragging. So, okay, you give us the hint to drag and explore. We start dragging, hide this thing, okay? So you remember that. I'm sure that you remember and you already know how to handle this. And we handle this in our island component in the function handle pointer down, okay? Where we are also using set plain animating, etc. So here is where we handle the dragging. So we can set this to false here, okay? So let's set this to false here on this handle pointer down. So to be able to set that to false, we need to pass this as a prop, right? We need to pass this set show hint as a prop to the Fox island from the parent component, which we are on the home page. So here set this to false by passing the prop. So pass the prop here. Okay. Now that we pass the prop, let's get the prop here with the other props. We have the prop, and here we simply set this to false. It should be okay now. Isn't showing, let's check. Yes, I see the bug. I see the bug. I added two set show hint here, but it should be simply show hint, not set show hint. Okay, I made a mistake. Sorry. So show hint, set show hint. Usually this is what we do. A state variable and a function to update the state variable. So show hint. We just passed this set show hint. You see, we have show hint here. It should be solved now. No, okay, let's check. It seems that we have a problem with this. Oh, okay. I imported with curly brackets. Yeah, that was the problem. You see, now it shows correctly. Click and drag to explore. I don't know why I imported it with curly brackets. Okay. Okay, so this is done. It looks nice. I like it. Now let's click. It should hide. Yes, it works correctly. I also added the styles for this in my Homepage.css. So the hand icon container, just the position absolute at the bottom 40 pixel. At the left 50% is like to put it in the middle. I added this swipe animation. And yeah, these are the styles. You can copy these styles. Okay, I also added the styles for the mobile. But if you need that, you can download my project. Now, let's go and add the other 3D model animated that I mentioned, which is the bird. I have here in my assets the folder for the bird. Okay, this GLTF is too large. So let's convert also this with gltf.jsx utility as we did with the other models. Okay, so open a new terminal window to leave, live the project. and go to this directory where you have, your bird model, or if you want to add something else, it's your choice. So I have it here, src assets bird. So I am at assets bplane. Now I am in assets cd bird. Okay, so here, since I am on this folder, in the same folder that we have the scene.gltf, let's run the command that you are now familiar, mpx gltf.jsx, the name of the file of the module, which is scene.gltf, always scene.gltf, and the option -- transform to make the project optimized. Transform. We created this scene component. Let's check it. Okay, you see, like with the bplane, we have this always nodes, materials, and animations from the useGLTF path that we will create also for this, a variable for the scene path. And also the actions, the same as with our bplane, actions from use animations, also here, actions from use animations with animations and group as arguments, because it means that we have an animation for this bird 3D model. So this utility, gltf.jsx, recognizes this animation from the file gltf. So it automatically imports these actions to use the animation. Okay? You remember how we did it? It's basically the same thing with just, a small difference. We did it like this here. We use these actions that the name of the animation, this is just animation, but it's not always like that, because this may change, and in this case it will be different, not animation. So actions, the name of the animation that we will console log and find what it is, then calling the method play, and here calling the method stop if we want to stop it, and pass in the dependency array the variables that we want to watch to re-render and change our page. Okay, so let's do the exact same thing, but with a small difference in logic. Here, we need the use effect, right? So let's get the use effect from React. Now, as we always did, we use this scene path, okay, to use this scene transform glb, that is the file newly created, and use this variable here. Don't forget this part. Also in the end, this file is smaller, 50 lines of code. You can see the difference, how many lines of code there are in the gltf file. You see in the row gltf from Three.js file, you see, crazy. There are 5,000 lines, but here we have only 50 lines. You see the difference, what this utility package does. It really makes it easy for us. So let's use this use effect. Add the comment, this use effect will run when the component mounts, as we know. Okay, and it will start the animation. So here, I used the snippet for the use effect. So here, simple as that, as we did with the biplane, we use these actions to access the animation that we've found out with console log. So let's console log these animations and see what is the name. Let's comment this so we don't get an error. But we are not calling this on our home page, so it will not show. Also, I think I am console logging the old biplane. Let's check. Yes, we are console logging that, so let's comment it so we don't get confused. And let's call this from model, call it bird. So let's call this bird here in our home page. We see the bird, you see? It's in front of us. Okay. Let's see the name of the animation that we are console logging. Animations of the bird. I added this tag. And the name of the animation is flying. You see here in this array animation clip, we have the name property, which is flying. So let's target this flying. With a biplane, it has the name of animation, but it depends how, it is called from the GLTF imported. So let's use the flying name. Uncomment this. I don't need this return. Here in this third, I will add the actions, just the actions when the animation changes. Here, let's call these actions, simply as that. And remember, with the biplane, we accessed this name of the animation, which was flying, and the method play. Okay. And the animation plays, as you can see. Nice. It's a nice bird. It looks nice. Okay, we don't want it like this in front of us. Of course, we will make it that this beautiful bird will move from left to right, animated, and will show like, it is crossing the screen. Let's do that. So the logic here is make the bird move from the left of the screen, cross the screen, go at the right of the screen, outside the screen, maybe we want to make it appear again at the left and cross the screen again in a loop, okay? Let's do that. So we also used the hook useFrame previously. So you know that the useFrame hook is used on each frame. So that is most suited for the animations part, okay? So whenever we have animations, we want, to render them on each frame. So we need this useFrame hook again. And this is from React 3 Fiber. So useFrame from React 3 Fiber. Call the useFrame here. Inside the useFrame, we will add the logic, so the bird crosses the screen from the left at the right, it ends the screen, it will display again from the left to the right. We will also rotate this bird because it is in front of us now, but we want to show it, on the side, flying in that direction. Also, it is too big because it's the size of our plane, so we will make it smaller. So change the scale, change the direction, and yeah. display it from left to right. Let's change first the rotation. What if I change this y-axis? Oh, I changed the B-plane. The bird here. So change to 1 on the y-axis. Yes, this is the direction that we want for the bird, okay? It will fly like this. Now let's change the scale, make it smaller. So I think that was the default size, so 111. We will make it like half of it. So 0.5 or maybe 0.4. Let's try and see. And we will change it again if needed. 0.4. Yes, I think this is the perfect size actually. You know, seeing the plane, this is, you know, the perfect size. Like we see that the plane is near us, the bird is a bit, you know, but looks good to me. I think let's leave this size. For the position will change during each frame. At least the position on the x-axis, from left to right. We will use vector 3 for that. Let's do this logic. Here, in the use frame, where is it? Oh, here, in our scene component, use frame. The logic is move the bird from one side to another, so from left to right. To move the bird from left to right, we will change the vector 3. We will add a vector 3 to its position and we will change it, okay? We'd like a velocity that we will decide. So for that, to do this kind of manipulations, you know, on each frame, we said that it's a bit expensive, you know, to do animations on each frame. And you see here that our utility gltf.jsx already added this const group equal useRef. So we have this reference and let's use that reference for this group. So to change the position, it will be group ref. No, group, simply group. The name of the variable is group. That current, remember current, that position, that add, and here we will add a new instance of the vector 3, new vector 3, which will take 3 arguments for x, y, and z. And we want to change the x, right? So for the x, we will add here 0. That's because it will be too much, 0.1, 0.005. And for the y and the z, we leave it to 0. This 0.005 will be the velocity that it will move. Okay, so you can change it accordingly as you need it. But let's try with this first, and maybe we can change it later. So this is, you see, the bird is changing its position from left to right, and it looks perfectly. But now that it went off screen, we won't see it again, because it is changing like infinitely. Okay, so it's like going that way. We wanted that when it goes off screen, turn it back. Okay, turn it back here at the left and display it. let's add a condition for this. So let's check the screen. If the bird on the x-axis is more than, let's say the screen is from 0 to 1. If it's more than 1, then reset its position and make it appear again at the start, so at the left. Okay, let's do this condition. I want you to guess this logic yourself. I want you to think when you want to implement a new feature or logic that you might need in your application. I want you to go through this process thinking, because this is very important. I don't want you to come back here for every small thing. I want you to think like that, to know what you exactly need and how to solve this. Okay? So we change the position of the x-axis, but our bird is going like infinitely, going to Mars. So let's turn it back. Let's add a condition with if, not with a turning operator here because we are outside the JSX. So if we said if it's more than this screen, so the value of the screen, let's say from 1 to 10, if it's more than 10, turn it back. So if our model, which is the group ref, if group.current always current, dot position and dot x, because it's the x-axis that we are talking about, okay, is more than, I don't know, more than 5, is more than 5, then what we want to do, we want to reset this boundary. Okay, to reset it, we reset it is more than 5. Let's make it -5 then. Okay, so it's logic. It's more than 5. Let's make it -5. So let's set this position to -5. So group dot current dot position. You can use that x if you want to set only the x position. When you want to set the 3 axes, okay, to have like an exact one, you use the set method. So set. And here you pass inside the 3 arguments, x, y, z. So -5, we can make it 0, 0 or 0. So the z axis, let's try 0, 0, then we can change it. Okay, if it's more than 5, reset to this. Let's add this boundary. And here, reset. And the else condition, what will be the else condition? Can you guess it? Yeah, the else condition, we already have it, right? It's this. If it's more than 5, just reset the position. Else, just change the x with this velocity. Let's check. Nice. Our bird is flying. It looks nice. I like it. Let's see when it goes off screen if it turns back. Go, bird, go. Yes, it turns back. Here at this limit. Let me see it again because it was like it didn't go completely off screen. Let's see when it... Okay, it's exactly here that it... Let's make the boundary a bit more than 5. So 7 and here 7. Let's check again. Yes, it comes back and it goes completely off screen, then it turns back. Yes, 7 looks okay. To make it delay a little bit more, we can add like 10 and then, you know, but it looks great. I like it. Okay, and this is done, guys. To me, it looks very nice. We can add more than one bird. It's your choice. If you want to add more than one, you know how to do it. Or I will leave it as a challenge to you to add more than one word. And this part is done. I think we are done with the main scene. We have like a beautiful scene. Maybe what is left now is like to add the other pages, like the menu bar with the other pages, like about me, projects, contact, etc. Right? You see, now you know the logic. If you want to add another model with another animation, I think you can add it now because you know how to do it. And this is what I want from you. I want you to be able to create things yourself now, okay? Don't rely on my tutorial anymore because you know how to import a 3D model to the web, okay? You know how to convert it from GLTF to a JSX component and an optimized component. You also know how to add the animations. So I think you can customize this based on your needs and you can create your unique version of it. It's very customizable, I think. So let's continue with the other parts by adding the pages. So I added the menu, as you can see, and all the other pages, and they also have the routes. So if I go to about me, you see, then I can go to my projects, some of my projects. I also have the contact page, and here is what we will do on this tutorial. We will add a new model here, a 3D model, and that will be a fox, since the theme of our main 3D scene is a foxy island, okay? So we will add one of these foxes here. So one of these models, we will add it here. But the cool part, it will be, I can show you the final result. So you see what we are going to do. So you see we have this fox, and where we are not interacting with the contact form, the fox plays this animation, you know, moving its tail. But if we go and interact with the input field, you see the fox starts walking, it plays another animation, and this is a cool feature. But check now, if we send an email, what happens? So let's say I send an email. You see, message sent successfully, and the fox starts running. It plays another animation. It's very nice, if you ask me. So now the fox turns back at its idle animation. We received the email here, you see. New message, test. So it also works, by the way. So this is what we are going to create now, because for the other pages, like about me, my projects, etc., and testimonials, yeah, you can go and download the project, you know, copy the styles and everything, because maybe there is no need to create all this from scratch now, because it's JavaScript and CSS, so it will be a lot of work. So you can do it yourself if you want your own version, or if you want to make it like mine, you can download the project at the provided link. Also the same thing for the menu here. We are not going to do it from scratch now. You can download it there, copy those styles and JSX elements and add it to your project, or create a brand new one as you like it. Now to create that cool feature with a fox animation, we need to create a new component. Here I have inside the src, I have this pages folder with the pages, so about, contact, projects, etc. Add other pages if you want. I added here the basic template for the contact page. Okay, you can create one yourself, or as I said, you can copy the code in the provided link. But yeah, it's a simple contact form, and you know, with the icons and everything. So here it is. Okay, this one. And here we will add our fox with its animations. So after creating this form, let's create the component for the fox 3D model. And as always, we are going to create it with our utility package, gltf.jsx. So after downloading the assets, also for the assets, if you want the exact assets that I'm using here, of course you can use not the fox, but use another 3D model. You can use another 3D model of your choice, your own 3D models, or one that you download for free on internet. So it doesn't matter. If you want the exact project as I have it, you can download the project. So you can have it exactly like this. So if you are using your own 3D model, put it here in your assets folder. I have it here, fox. And as you can see, it has the scene.gltf and scene.bin. So let's go to that folder as we previously did. I am on the bird folder, so let's go back, cd that. Now let's go to fox folder, cd fox, and here let's run the same command, gltf.jsx, the name of the model, scene.gltf, and the option transform. Our component is created. Let's open it. Now you see the same as the other components that we had, like the plane, the sky island, the bird. So also here we are importing the nodes, materials, and animations. We are using these actions from the useAnimations hook that returns an object with the animations, and we are going to explore what the names of these animations are so we can target them. And as you know by now, we use the useEffect hook to create side effects when the component mounts. And here, let's use these actions inside the useEffect hook to target our animation and play them. But first, let's console log the animations so we know what animations do we have, what are they called, etc. Not sure we are also console logging the bird animations. Yes, so let's comment this. So to console log this and to, to display it in the page, we need to call it on our component, parent component, where we are using this 3D model. And we will use it here in the contact component. Okay, not in our home page, but in our contact component. And here, let's import this. Let's rename first its model, but let's rename it to Fox. Also, we forgot to change this path. As usual, we create a variable, import sim path from this scene transform GLB. Use the path here and also in the end. Now let's import this Fox here. Assets, Fox, and scene. Okay. We also need the canvas, and the canvas we imported from React 3 Fiber. Then call the canvas inside this contact component, and I will add it here inside this main div contact container. I have an empty tag, so I can add more than one component. If not, usually you get an error. So let's create also a div for this canvas, like a container for the canvas. Inside called canvas, I want to add some properties to this canvas, like position, field of view, the near and the far, etc. So camera equal, you have two curly brackets inside, and first position. Then the field of view, the near, and the far. Also, we need some lights, because if not, we are not going to see anything. So ambient light with intensity to 0.5. Then the point light. I will set the position to 10, 10, 10. I also need the spotlight. 10, 10, 10 also. Add an angle, 0.15, and the penumbra. Here I can call the Fox component and add some properties to it as well. So position, rotation, and scale. And these are some values that I tested it previously. The scale 2:2. Okay, the reason I have an error for this scene transform GLB is because I don't see it here. And this is probably because I made an error when I ran the command with gltf.jsx with the options -- transformed, because that is responsible for that transformed GLB. So let's check. Okay, as I said, I made a mistake, a typo here. Transform, it should be transform. So let's run that command again. npx gltf.jsx scene.gltf -- transform. Okay, I have now this file, glb transformed. Let's do again the same path. let's console log again, because I lost the previous code when I rerun the command. Oh, the name here, model to fox. Okay, I know what's the error. You see this canvas. This is inside here, the canvas. The lights and the fox, of course, are outside this tag. But the camera is inside this canvas tag. Let's see. Yeah, great. We have our fox. It is not animated yet. We should add that, but the position and everything looks correct. Just some padding here for the form, but it doesn't matter. So we said that we want to change the animation of the fox based on the interactivity of the user. If we are not interacting with the contact form, the fox will play the animation idle. So it will stay like, moving the tail and staying idle. Then if we press here in the input field, if we write something, we want the fox animation to be the walk animation. So the fox starts walking. And then finally, when we send the email successfully, the fox animation will be the running animation. So based on this, we create the logic. What's the logic? The logic is first of all to set a state variable to check the current animation. So based on that current animation, we will play one of those animations that we have for the fox. But did we console log what animations do we have? Okay, so we have an array of animations and we have 1, 2, 3, 4. 4 animations. As I said, we have the hit, which is the running animation, the idle, and the walk. We also have another one, walk left. But yeah, we will use these 3 animations. Idle, walk, and hit, which is the running animation. So we know the names. Hit, idle, walk. Let's target those names. And here in our scene component, let's use the use effect. Here the dependency array, we will check for the actions, if the change to re-render, and also for the current animation, which will be the current animation that we will set as a state variable that we don't have yet, and we will create it now. But let's pass it here. Current animation, which we will get as a prop here. So let's add curly brackets for an object, 3 dots for the rest of the props, and here current animation. We added this as a prop because we will pass it here as a prop after creating the state variable. Okay, we started from the end, but it's the same thing. Here, let's create a state variable. Current animation. Set current animation. And the default one will be the idle animation, because when we are not interacting, we want to play the idle animation for the fox. So here the name of the animation is idle. Let's pass this current animation as a prop, where we are calling the fox component. So here we know now how to pass the props, right? we have this state variable. We passed it as a prop here, and we are using it here in the dependency array. So to let the useEffect know what it should look for to re-render. So let's add the logic now. I will add this code, object.values, parentheses, and inside let's add actions as argument, dot for each, and for each action we return action dot stop. So what we did here, inside this useEffect, we first stop all the running animations by looping over each action in actions, and then we call action.stop for that action. So we stop all the running animations with this, okay? Because first of all, we don't want the animations to run. Then we can check with a condition to check what is our current animation, then display what we want and play it. And here add the condition if actions array current animation, curly brackets, actions array current animation dot play. Is it clear for you guys? Here we are checking if there is an animation that matches the current animation. If there is, we play that animation with this actions current animation dot play. Okay? Now we need to set up the logic for each animation, when and where to play it. So here in our contact component, let's create the 3 phases for these animations. So we need to create 3 different functions. So const, let's call it handle blur. Also const handle focus. When we focus on one of the inputs and interact with the input, and it will play the walk animation. And the third one is when we send the email and we want to play the running animation. So const send email. We have these 3 functions. We need now to add the logic inside. For the first 2 is very simple. We just change this current animation state from idle to walk for the handle focus and leave the idle for the handle blur. Okay, so for the handle blur, set current animation to idle. For the handle focus, set current animation to walk. These are the names of the animations, don't forget, that we console logged. And for the send email, we will add set current animation to, it was hit for the running. The name was hit. Here in our send email function, of course, we need to add some other code because we want to handle the contact form to be able to really send an email. And we will do that with a library called email.js.com, something like that. I will show you later. First, I want to test something, so let's pass this handle blur, handle focus to the input fields, just to test a bit. So here on focus, we add this function that we have, handle focus. And for on blur, this is suggested, guys, you see? That's why we called our function with that name. So on blur, we pass handle blur. Copy this and add it to the other input fields. So on each of those input fields we interact, we will play these animations. Also here on submit, use effect is not defined, so let's import it. You see, now we are playing this animation. I go and click on the input fields. It starts playing the walk animation, so it works. The only thing left is to send an email and play the running animation, okay? But it works until now, so we don't have any issues. For the last logic, to send the email, here in this function send email, we set the library email.js. Let me check, I have it on my package.json. Email, what is this name? Okay, email.js-com. So you install it with npmi email.js-com. Install it. I already have it. You install it first this and then import it. Here at the top, import it. Import email.js from email.js-com. Okay. Also, we need a reference to the form. Remember the hook useRef? We need now a reference to this contact form. So let's create a reference here at the top. Simply const form equal useRef. Then scroll down to form. Okay, here you see form, or where you have your form, depending how you create it. If you use my code or you are just creating your form, maybe with an external library, doesn't matter, but here where we have the form, add the reference with ref. Inside it was form, the name of the variable. Okay, so form from useRef. Also, we need to add the onSubmit. You know, when we work with React, if you are familiar, we add the eventListener onSubmit and pass a function to it, what we want to do when we submit the form. So when we, fill the input fields and we submit that. So what we want to do with that? We want to pass the function send email, that we want to complete that function with the code for email.js-com library. But first, let's pass it here. So on submit, pass that function, which has the name send email. Okay, so we are good to go. What is left is the logic inside this. First thing first, pass here as an argument the event, so just an E, as we usually do. Usually you use event.prevent default. Then here, let's use the library email.js that we imported at the top. And this has a method send form with some arguments. The first one is the email that you will register. You should go to Google, search for this email.js-com library. You should sign up for an account there, create an email, then pass here your email. Okay. As a second argument, you pass the name of the template that you create on that website, because on that website you will create a template. How do you want the template to receive it from, from email.js? So after creating a template, you get the name of that template there. You will have a guide for that in the website. So get the name of that template and pass it here. Name of the template. The third argument is form.current, the reference that we have here. Form.current, the current form. And as the last argument, you pass your user ID that you get there on that website of email.js. So your user ID. And here .then, we use a promise here. If you don't know what promises are, I suggest you to check on YouTube or on Google about promises in JavaScript, because this should be a lesson apart. Okay, so check promises and async operations in JavaScript. So here then we get result and we pass an arrow function, and inside this function here we will use another state variable which will be responsible for the message sent. Okay, so for the notification that we display message sent successfully. So let's create a state variable for that. So at the top here, let's name it notification message. And the default value will be null. So notification message. Here, let's use this state variable, notification message. We want to set this notification message from null to the text message sent successfully. And you know by now that to change the state variable, you use the function set that updates it. So set notification message. Inside, we pass the message as a string. So message sent successfully. Also here, we have the possibility to set the animation that we want to play after the message was sent successfully. And here is the running animation of the fox, which had the name hit. We console logged the names, remember? And for the running animation, the name of the animation was hit. So let's use the function to update this current animation. We'll set current animation. To hit. And we want to let this message display for a few seconds and then hide it, okay? And for that, we use the set timeout from JavaScript. Again, if you don't know this function set timeout from JavaScript, check Google and learn more about it. But basically, we set a timeout. We set like 3 seconds for this notification message to display, okay? In this case, we want, after 3 seconds, we want to hide it. So not to display it anymore. And we will make it null again after 3 seconds. To make it null again after 3 seconds, call setTimeout method. Here, it's an arrow function. And we return this state variable. And here we want to set this notification message to null again. So set notification message is the function that updates the state variable, remember? And as arguments, we pass here null as the default state it has. And here, comma, 3000, meaning 3 seconds. Okay, so this 3000 is passed on this set timeout, and this null is passed as an argument to this function that updates the state variable. Okay, don't get confused. So we use set timeout, we use 3 seconds, and here we set this notification message to null. So it will be null after 3 seconds. And this is done. But usually with the promises, we also want to catch the errors. So here, comma, to catch the errors, we pass another error function here, the argument error. Here, again, we use the notification message, set notification message, a text for the error, like failed to send the message. Okay. Again, the same thing for the error message. We want to hide it after 3 seconds. Okay. So we added the reference to the form. We added on submit this send email. Let's try what happens now. Send. Okay, we run the Fox, but we are not seeing the notification message. But the animation runs. And of course, for that, the problem is that here I didn't add my email, the template, and the user ID from email.js, the library that we used, okay? If I add here my email, the name of the template, and the user ID, it works. So this is what you should do. And this is done. We have this very cool animation of the fox. And I think this will be a unique way to make the contact form. And I'm pretty sure that the users will love it. And let me know your thoughts. What do you think about this? Alright, it seems like we have reached the end of our journey in creating this 3D portfolio website using React 3 Fiber. Let's take a moment to appreciate all that we have accomplished. We have learned how to integrate and animate 3D models in a website, and also how to make them respond to user interactions in real time. I hope you have enjoyed this journey as much as I have. And more importantly, I hope you have learned a thing or two about creating engaging web experiences. Remember, coding is not just about following rules and syntax. It's about creating and exploring. And if you ever find yourself stuck while implementing these new skills, remember that it's not a bug, it's just an unexpected feature. On a serious note, always remember that programming is a constant journey of learning and exploration. If you enjoyed creating this 3D portfolio website, I encourage you to continue exploring this exciting world of 3D web programming and beyond. So what's next on your coding journey? Please let me know. Before we part ways, make sure to hit the like button if this tutorial was helpful, and subscribe to my channel for more exciting web development adventures. Remember to keep exploring, keep learning, and most importantly, keep coding. Until next time, this is Emilian signing off. Thank you.